Looks like Wade got it on Skype.
Yeah, let me see if I can get him.
At least he thanked you for the credentials that I saw on Skype messaging.
443. Yeah, so we are live again, everybody. And we're going to start off the second part of our event here. So someone is calling me that's trying to get on, I think. Hey, how you doing?
Is that Wade?
Hold on for a second. Simon, you with me? Yes. Yeah, did you get the second email? We switched to Zoom. Yep. Yeah, okay. All right. All right, take care. So everybody just kind of bear with us a little bit. We are getting people logged in. And here we go. There we go. There we go. Okay. All right. And we got Marcello Souza on with us. And so the second part of our Global Star Party, the Global Star Party 6, we were going to start off with our friends in the Southern Hemisphere and also in the Philippines. And so we have with us right now Christopher Go from the Philippines. Dustin Gibson is on with us from OPT and Gibson Picks. Got Gary Palmer from the United Kingdom with us. Rodrigo Zaleta from North Optics down in La Serena, Chile. Steve Molly is with us, Ontario Telescopes in Canada. Jason Gazelle, the Vast Reaches, is with us. And we've got Astrobeard, Richard Grace with us as well. Of course, Jerry Hubble and David Levy decided to hang out with us for a while, which is really cool. And Marcello Souza is attempting to connect with his connection down there. So we'll get him in a minute. Marcello is a cosmologist. He runs an annual event, which unfortunately might have switched to a purely virtual type of event. Of course, we can't do this any other way. And have a global star party and bring the world to you, Northern and Southern Hemisphere, Asia, Europe, without us being online together. So, and 100 Hour Wade is now joining us. So that's great. That's great. So let's go ahead and get started, Christopher. I can tell you're all set to go here. So I'm going to give you the stage. Okay.
Well, hi, everybody. First of all, I want to talk about something exciting that's going on with Jupiter right now. Behind me is an image of Jupiter. You can see above, there's this bright, huge storm, which is in the north temperate zone of Jupiter. This is actually a common event in Jupiter, which happens usually once every 5 to 6 years. But this one just appeared early this year. It was supposed to appear next year, but this year you have this huge storm. This is actually going to go around the planet, and this has been studied as the fastest storm ever observed in the solar system.
Wow!
It moves at 700 kilometers per hour. Oh no, 700 miles per hour. In that direction, it'll go probably around the planet in less than a month. This is an exciting thing that's going on with Jupiter right now. And right now, professional astronomers are encouraging people to image Jupiter as often as they can, especially as this storm develops. This storm started as a spot last week. It was discovered by a Japanese amateur, Isao Miyazaki, who lives in Okinawa. And as you can see, this storm has basically increased in size by tenfold, and it'll get bigger and bigger as the weeks go by. So
Wow.
Jupiter is exciting right now, and of course, soon there will be a perijobe, which means Juno is going to approach Jupiter again. We're hoping that Juno will be able to catch the storm, so we'll have a very close-up view of the storm. So things are exciting here in Jupiter.
Yes. Yes. Yeah. So is this? I mean, being that this is such an unusual event, I mean, how would you rank this as far as on the excitement level from like a 1 to 10?
Anything that's going on in Jupiter is always exciting. Probably this is number two after that huge storm in Saturn.
Oh yeah.
Yeah, so that huge dragon storm, probably the largest storm ever. This might rival that storm.
Right. Well, Christopher, I know that you're a modest guy, but your work speaks for itself. You take some of the most amazing planetary images I've ever seen in my life. When I just think that it can't get any better, you make it better. And so, uh, you and I had a common friend, David Levy, and David, or excuse me, Don Parker,
Yes.
Planetary Amateur as well. David Levy is also a common friend too. But Don Parker told me a story when he was first making some of the really high resolution planetary images with the CCD camera. And he submitted them to a Japanese astronomy magazine, and they rejected his work because they said that that's not possible, okay, him by spacecraft, okay, and he had to prove that he was actually making his own work and wasn't. You mentioned the word doping, okay, image with the spacecraft image. How close are amateur astronomers that are doing planetary imaging now to achieving what, let's say, like the Hubble Space Telescope does now?
Well, compared to the Hubble Space Telescope, we're still so far away. Uh, in fact, Hubble is really much better. In fact, I'm going to show you in now. So that's my image. This is what Hubble looks like. So we're still, far away from Hubble, but we're basically getting images right now. Probably, I would say, very close to what spacecrafts were doing in the 70s.
Wow.
So, and basically, the quality we're having now is even the observatory images in the 60s, 70s, 80s could not compare to what we're doing now. Unless you'd have the recent observatory images using adaptive optics, that's when you can get better. So we're actually doing, in fact, right now, the reason why I encourage people to image is because professional astronomers actually use our images in the research right now. The quality of the images of amateurs right now are so good that professionals are using it to measure wind profiles of Jupiter and Saturn. It's that good right now. And right now, especially with the Juno mission, the problem with the Juno mission is it's so high resolution. I mean, it's like a satellite here on Earth where it takes high resolution images of the ground, and Juno is doing the same with Jupiter. But the thing is, the professionals don't have the wide view, so we amateurs are providing that wide view to them. So it's amazing time right now for planetary imaging. We have new cameras coming in, which are very sensitive to IR, and this is helping us improve the quality of our images.
Wow. Well, that's great. That's great. You have some questions here. There's people that are literally blown away by the image that you were showing earlier. One of the questions is, do you have a social media page where you post your images?
I have a Facebook page, but I also have a website, astro.christone.net, where I post all my images with commentaries.
Great. People are asking me about orthoscopic eyepieces right now. Obviously, these are people that are visually very interested in observing planets, and orthos are still great eyepieces.
Yes, they are.
Astrophotography question to you. Jupiter is a failed star. Mostly.
No, wrong. Jupiter is a planet. It's a planet, not a failed star.
Okay, there we go. So the question, I guess, do we still consider them the activity as storms?
Yeah. Well, first of all, let me clarify that. What is a star? A star is an object that has a core that does nuclear fusion. Now, Jupiter has an iron core. It has a huge iron core. In fact, it's heavier than our planet. Meaning, just imagine, when does a star have an iron core? Just before it goes supernova. So you have what you have. What we have. Jupiter is a planet. To be a star, Jupiter has to be 80 times. It's like saying that you have $17,000 and you're almost a millionaire. So, so it's nowhere close to a star. So it's a misconception to call Jupiter a failed star. Just as a person who has about $20,000, you call him a failed millionaire. Well, he could be a failed millionaire, but he's nowhere close to be a millionaire. So that analogy.
I think that misconception came from the movie 2010, Space Odyssey.
Right.
Oh yeah. So and also the way that Jupiter was created is different from the way stars are created. Stars are created with accretions of gas. Jupiter was created the same way Earth was created, with accumulation of materials that grew. Jupiter just grows so big and it caught more gas than the Earth. And for composition, most stars are 99% hydrogen helium, while by mass, Jupiter, I think about 13% of Jupiter mass is heavy elements. So Jupiter, let's put it to rest. Jupiter is a planet.
Yeah.
Put it to rest.
You're here.
Yeah.
Let's see. So let's go ahead and jump to Rodrigo Zeleda down in Chile. Rodrigo, how is your skies down there these days?
It's good.
Hi.
Today is a clear sky.
Cloudy sky again.
In 3 weeks ago is cloudy days, and I put my telescope and shoot to the globular cluster, 47 Tucan in the south.
Oh.
This I share with you the. The leaf imagine. Can you see?
It's starting. Oh, there we go.
Wow.
This is a real time for my telescope for the CMOS camera, the globular cluster. The color is maybe green for the light pollution filter. Tonight I move and the light pollution filter give the green color.
Yes.
Yes, and little process.
What application are you using?
Better with these clusters. And last week, last Saturday, I have 2 days of clear sky, and I take this picture from the Helix Nebula.
Mm-hmm. You're still on the globular right now.
Oh. Do you see the Helix Nebula or no?
You're still on the your globular star cluster.
Okay. Okay, this.
That's the helix. Yes, it is.
Yes.
That's a beautiful. That's a beautiful
Yes,
one.
La,
Oh, you made.
again, from La Serena, this 2 hours of exposition for CMOS camera and dual narrowband filter for the light pollution in the city.
Beautiful.
This is my presentation, Scott.
Yeah, thank you very much. That's great. Okay, all right. So being that we're still waiting for Cesar Brolo and Marcello Souza to come on, I'm going to, we're going to switch to Jason Genzel, okay? And Jason, how's it going out there?
Oh, you put me on the spot. Okay.
I put you. That's right. You weren't ready.
Another hour, but yeah, not so good with the imaging. It's been raining, so we're
Right.
got to switch gears a little bit here. Sorry, my camera's shaking. The you know, I was thinking I could just show a little presentation I put together. Actually, the one that I went through with you, Scott, a few months back, just about sharing astrophotography. So let me share my screen here. And I think I can share this presentation directly.
Okay.
Can you see this?
Oh, yes.
Yeah, so this was a little talk, and I think when I talked with you, Scott, we went through this in like an hour and a half. So obviously, I'm just going to skip through it. But it was just talking about a little bit about sharing the universe through astrophotography, as it said. And you know, most of the imaging I'm doing here is from my suburban backyard, and it's been a long journey for me. And I started out very simply, but over time, really started to become impressed with what is possible from a suburban backyard, just using more basic equipment. Are you able to see my whole screen? Because I have a pop-out window with the meeting in the corner.
Yes, I can see.
You don't see that?
It's in presentation mode. Yeah,
Okay.
looks very nice.
Oh, I can minimize it. Okay. So yeah, this is just a quick shot of the it's not a quick shot. I took about almost 30 hours of integration to get this, but you know, it's just a quick look at one of my images I'm proud of. This is the Cat's Eye Nebula, and you might recognize the inner core here of the Cat's Eye Nebula from the famous Hubble image, but surrounding that, and something you don't get with a narrow field of view like Hubble, is the beautiful intricate web of hydrogen and oxygen gases that surround that nebula. With a long exposure, you're able to bring that stuff out. And then that's an object that's relatively close to us at I think a few thousand light years, but this galaxy here is actually a 350 million light year distant galaxy. And so, you know, imaging these things from your backyard, you're able to get some unique views that maybe aren't possible through scientific telescopes. So that's what makes I think amateur imaging is still relevant and interesting. As I said, it's a long journey, you know, and I get a lot of questions from people through social media and things like that about, you know, how do you start, you know, or can I even do this? And I try to answer as simply as possible is yes, it's possible for anybody to do this. And the way to start is to jump in as simply as you can. If you have even just a simple camera to start with, you can start snapping pictures. And I have up here, you know, my first galaxy photograph that I took with my DSLR and a 50mm lens. I just put the thing up on a fixed tripod and I was going to see what I could get, you know, and that's 22 seconds of exposures. But I was jumping for joy when I saw this, you know, that I actually captured a galaxy from my back patio with just my camera. So obviously, you know, you can jump into it at little to no cost, but once you start diving deeper, it's can easily swallow your wallet. But you know, I tried to show what's possible, just an upgrade. You know, between these two pictures, this is the same camera. This is just mounted to a 6-inch Newtonian telescope and an equatorial tracking mount. You put an hour and a half of integration in it and a ton of processing experience, and you can pull out some tremendous detail in that galaxy.
Yeah.
And that just shows a one step further with a more advanced setup. You know, you zoom in a little bit more and you can see that this is just part of that galaxy. You can pick out individual stars in another galaxy. It still amazes me that these blue supergiant stars here are available to image from anybody's backyard, really. You know, I image under pretty substantial light pollution. But you can see, you know, the hydrogen alpha nebulae in the galaxy and individual stars.
Yes.
I won't take up too much time, but you know, I have in this presentation just a little bit about myself and the setups I use. You know, it's grown over time, but you know, I have a few telescopes and a few mounts and a few cameras, and you know, I've been able to put together quite a catalog of images with that equipment. You know, we talked a little bit about how to, you know, the right way to share this stuff online, because this is really outreach in the modern age, right? Posting your images up online and sharing. And I think, you know, what brought me back to this presentation and got me thinking about it was what Libby said in her little talk in the first segment. There's a lot of people that don't have access to space, don't have a telescope, don't have a camera, but there's a genuine curiosity from a lot of people in the general public. They want to know about this. You throw an image like this up, you know, on the right, you throw an image up like that, and they don't think that somebody's taking that shot from their backyard. They think that's a professional observatory or what have you. So it's always important, you know, when I share this stuff, I try to throw a little bit of science behind it, you know, explain how I came to take this image and you know, what they're actually looking at, because this seems like just a nebula, but you know, if you actually dig into the details of this image, there's actually a black hole sitting right here. This is the closest black hole to us, Cygnus X1. It's a
Right.
stellar mass black hole. And the tell, or the giveaway, is this blue arc here is actually caused by the relativistic jet coming out of the pole of this black hole and interacting with the gases surrounding it. So yeah, you know, I've got more in this presentation, just other images. We can flip through them if you guys want, or we can just leave it at that. But
We got,
you know, the
I'm-
outreach part of it, I just, you know, I always try to stress to people that, you know, it's important to interact with your audience, especially if you've grown an audience, and you know, engage them. And people are excited about it, and I think it's worth sharing, and it's worth starting that dialogue and bringing it to people that don't have access to it.
well, that's great. That's great. I'm, you know, seeing amazing astrophotography, it makes you look longer, your dwell time's longer, and that's important because you know, the more that you study, you know, I mean, like these towers where you see these stars coming off like seeds from the dark nebula, and just all the complexity there is just amazing, and it just makes you want to keep on exploring. So
Yeah, and part of the reason I put this presentation together was to demonstrate the variety of things that you can do and look at with backyard astrophotography. And I'll just click through the slides one after another here just to show them. But
yeah, please.
the beauty of things surrounding us never ceases to amaze me. Galaxies 50 million light years away, nebula within our own galaxy. Here we see the plane of the Milky Way as a horizon line and the approaching Andromeda galaxy off in the distance. The constellation Cassiopeia in the bottom. Planets, I mean, I can't, I'm following Christopher Go here, but this is, Mars opposition from 2018. We have another one coming up in just about a month. So it's a great time to image Mars. So many planets up right now. You can take a tour with your telescope and see almost all the large planets in one night. And of course, Venus, the atmosphere of Venus image.
Yeah, now that image really impresses me. You don't often see, detail on Venus, visually or in photographs. You just, it's pretty much so bright that things get blown out. And, you do have the atmosphere there. I don't know if we're seeing any surface detail or not, but it certainly looks like it, like you're able
No, the atmosphere is too dense, but you do see some variation in the cloud deck shooting through infrared and UV filters. So that's what I did in this image.
Mm-hmm.
And of course, I use the Explore Scientific 152 extensively for solar. So there's some, high detail sunspots and a look in calcium light. Prominences. And here's actually a video, time-lapse video of some prominence movement.
Oh, wow. Excellent.
And the moon in full colors. And the colors just relate to the chemical composition of the surface. So you can saturate that out and get a good look at the surface, unique look. Comets, another thing that's in motion up there that are accessible through backyard telescopes. We just had a great one. This was the one that was supposed to be the great comet of the year, Atlas. This was shot.
Are these asteroids or what is this?
This is Comet Atlas.
Above the comet, you can see.
Yeah, those are just satellites. Yeah,
lights.
Starlink. I don't know.
Starlink.
Speaking of satellites, International Space Station transit.
Yeah.
Cool thing to shoot.
Very cool.
Of course, Milky Way and nightscape stuff is always a fun thing too for someone just getting started.
Yeah.
And special events, eclipses and solar eclipses.
Beautiful.
Yeah. So anyway, yeah, that's it. So just a quick tour of my photography.
Yeah. And people can find you on Instagram. Looks like you're very active in social media. Where do you post most of your work?
Most of the stuff is on Instagram. That's kind of where I tell people to look because I stay current on there. Mm-hmm. So my handle's at the Vast Reaches. It's right there.
Yep.
Yeah.
Great. Well, Marcello Souza was able to get back with us, and so we are going to go down to Brazil. Marcello Souza is a cosmologist. He's a physicist. He's run a regular television program on astronomy, and he hosts large-scale annual astronomy and space exploration events. If you're into astronomy or space exploration in Brazil or anywhere in South America, you definitely know who Marcello is. Marcello, I'm going to put the spotlight on you. How are you?
I'm fine.
That's
Thank
great.
you very much for the invitation. It's a
Yes.
great pleasure to be here. Greetings from Brazil.
Well, you have the stage.
Okay. Can I share a presentation here? Scott,
Yes, you can.
I don't know how to do this now. I'm not finding here.
Of your screen, if you put the mouse over your screen, you will see a green button and it says share screen.
Unfortunately, I'm not find. Ah, yes, I found. Okay.
Okay.
Okay. Thank you.
Mm-hmm.
Right. Uh, I wrote a script for my presentation because as a limited time, I am trying to be in time. I studied cosmic strings, is what was my research in cosmology. That is a topological defect which may have formed during the asymmetry breaking phase transition in the early universe. But I'm not going to talk about this. In this presentation, I will tell an extremely brief history of the evolution of the humanity's view of the universe. I will start with an excerpt from a poetry. I need only to make a change here. On a moment. Okay. I need to move. Okay. This is a Portuguese poet, Fernando Pessoa, and in an excerpt of a famous poetry, he says that the universe is not my idea. My idea of the universe is that it is my idea. That is our way that we imagine the universe. We build models to understand the nature. And we know that astronomy is the oldest of the science. The ancient peoples only need to look at the sky to marvel at the beauty of the nature. In a place with little artificial lighting, it is possible to have an idea of the sky observed in antiquity. One of the wonders is the observation of our galaxy, the Milky Way, because I'm going to talk about the Milky Way. And they realized that there were 5 bright points that moved between the constellations, the 5 planets visible to the naked eye. The conception of the universe of humanity over a longer period consists basically of a geocentric model. We consider the Earth in the center, with the sun, the moon, and the planets around, and with a border composed by a layer of stars. We have many other people that create different views for the known universe in different periods of our history. During almost 1,500 years, the Ptolemaic model was the best model produced by humanity. I will not discuss the important paradigm shift with the change from the geocentric model to the heliocentric model. These are some fantastic images. This is from Robert Feders of the Milky Way. I had the opportunity to see in the deserts in Chile. That is a beautiful place to look to the sky. Yes. Another beautiful wave is from Ruslan Mesliakov. These both images were in upwards. Here is the division of the first vision that we had of the universe, with the layers of stars. And during almost as I said, 1,500 years, the Ptolemaic model, a geocentric model, was the best model produced by humanity. But Nicolaus Copernicus' heliocentric model was brilliantly defended by Galilei in 1609, and we celebrate the International Year of Astronomy in 2009 because of the contributions of Galileo. It was an important moment for astronomy. Here, Copernicus' contribution, here is Galileo, and the use of telescope. And for this presentation, I will highlight the fact that he observed that the Milky Way is a region made of a large number of stars. Isaac Newton was born in the year of Galileo's death. The Newton's law of universal gravitation changed the way we understand the universe. Thomas Wright, an English astronomer, wrote the book An Original Theory of a New Hypothesis of the Universe. In this publication, he explained the appearance of the Milky Way as an optical effect due to our immersion in that locally, in what locally approximates to a flat layer of stars. Is the first then, and here his idea was considered by Immanuel Kant and by William Herschel. We had gone from a model where the Earth was the center of the known universe to a model where the Sun was the center of the known universe. Now the Sun is in a region with other stars. It is an important philosophical change. Another of his ideas, which is also often attributed to Kant, that is the idea of the island universe, was in his book, and he wrote, like the many cloud spots just perceivable by us as far without our star regions, in which the visibly luminous space, no one star or particular constituent body can possibly be distinguished. Those in all likelihood may be external creation, bordering upon the known one, too remote for even our telescope to reach. What is the idea? This is the model of the island universe from Kant. And in this period, nobody believes that we have different regions in space, like the Milky Way, and they call the Andromeda as a nebula. But everything changed. This is the model produced by William Herschel of our Milky Way. And the American astronomer Henrietta Leavitt discovered in 1912 the relation between the intrinsic brightness and the period of Cepheid variables, a kind of variable stars. And as a result of her work in knowing the period of the variation of the brightness of the Cepheid variable, it's possible to know the distance of the stars. This is very important because this information that allowed Hubble to calculate the distance between the Andromeda galaxy from us. After her death, Edwin Hubble determined in 1923, here's the result of Leavitt, Edwin Hubble determined in 1923 the distance of the Andromeda Nebula using a Cepheid star. Here is the image of the Cepheid star here. And using the model of Leavitt, he proved that this nebula were too much distance to be part of the Milky Way. We return to the idea of Thomas Wright and Immanuel Kant. And the Milky Way was a galaxy, and we have other galaxies in the universe. This was another important philosophical change. And then we had gone from a model where the Earth was the center of the known universe to a model where the Sun was the center of the known universe. Then, now to a model where the Sun was in a region with other stars. Now, the Sun is a star in a region where there is a concentration of stars, and there are other regions with concentration of stars. Spectroscopy is a very important tool for astronomy. Each chemical element has characteristics spectrum lines. Analyze the spectrum, we know the chemical composition and the velocity. Here are two elements, hydrogen and oxygen. And the VESTO, here some stars, the absorption lines of stars. And the VESTO sleeve performed the first measurement of the radial velocities for galaxies and discovered that distant galaxies are redshifted. Combining his own measurements of galaxy distance with VESTO, this theory, the results obtained by VESTO's leaf was very important to Hubble, to Edwin Hubble. And Edwin Hubble combined his own measurements of distance galaxies with VESTO's leaf measurement of the redshifts associated with the galaxies. He, Hubble, and Milton Humason discovered a proportionality of the object's distance with their redshifts. Edwin Hubble and Milton Humason, that was a fantastic person. I don't know if everybody knows his history, but he worked with Hubble, and this result was the base that we consider now the universe in expansion. Expansion of the universe begin with the contribution of Hubble, but not all the galaxies are moving away from us. We have galaxies that approaching the Milky Way, as in the case of the Andromeda galaxy. What happens is that in the local group, the gravitational force makes the galaxy to approach. Now we are considering a expanding universe, but in the local groups of galaxies, the most important are the gravitational forces between the galaxies. Then we are talking about the galaxies that are very distant, that are long distance from us, but all the galaxies that are not in our local groups are moving away from us. Then in George Gamow, here is an image of the moving of the galaxy, the local group, the expansion of the universe. And George Gamow, based on the data initially presented by Hubble, put forward the hypothesis that the universe would have had a moment in the past with extremely high values for its density and energy. From that moment, the universe began to expand. According to the Big Bang model, the universe expanded rapidly, fast, from a highly compressed primordial state, which resulted in a significant decrease in density and temperature. Soon, the dominance of matter over antimatter may have been established. Nobody knows how this happens, because one of the problems that we have in the model is that we don't have so many antimatter, than we have matter in the universe nowadays. This is one of the problems that we have in the model, that we don't have an explanation for this. During this stage, many types of elementary particles may have been present. After a few seconds, the universe cooled enough to allow the formation of a structure of a small nucleus. But the theory predicts that we can, in the Big Bang model, we have only light particles like hydrogen, helium, lithium were produced. Their abundance now in the universe agreed with the observation. But we have many problems with the model. It's the best model produced by humanity. We have a moment in the beginning that you have high energy levels, and the universe begin to expand, and we have a moment that you have the domination of radiation. After that, like we have the phase transitions that occur when you have the water transforming in ice. Then we can imagine as a simple model about what happened with the universe when they cooled and during the expansion. Then we begin to have transitions, phase transitions. Then you have the appear, the first matters. Then we don't know how these structures begin to produce large structures in the universe, while in a place we have a kind of anisotropy, in the other place you don't have this kind of anisotropy. But this is a quickly view what we are to have in the universe, in the expansion of the universe. Now, the observed results indicates that the universe is expanding faster than was predicted, and we have considered that some kind of energy that is doing this, that we call dark energy. Then our view the composition of the universe nowadays, we have only 5% of the universe the matter, as we know. 25% is dark matter that is we have to consider to explain what happens with the rotation of the galaxy, and 70% approximately will be the dark energy. This is our composition of the universe. This is a brief history. I hope when I was trying to make a brief history, I missed some important information, but I tried. Thank you very much, Scott.
Thank you. Thank you very much. Thank you. At this time, we're going to go back to Christopher Go. You mentioned that you have some exciting news.
I have some exciting news right now because I just received a message from my friend Eric Susebek. He lives in the Caribbean. And what's happened right now, there's a new outbreak. If you look at behind me, this is an image from the, Eric was just processing his software, and you have that bright spot. This is a new outbreak on the NTB. This is just a fresh discovery. So we're very excited. This is the second outbreak in that region. So we're hopefully I can image this region tonight, but so far Eric has made this discovery today, which is very exciting for us. Now, this storm is actually a huge giant thunderstorm in Jupiter. You can see that this storm is very bright in methane band, which means that it is a very high altitude storm, which really punched through up to the troposphere. If you notice, these storms are even higher than the Great Red Spot. So these are very vigorous thunderstorms that occur in Jupiter. So yeah, it's just exciting that you get these discoveries from ordinary imagers that come out almost 2 weeks ago. There was one, and there's this one. You can see amateur astronomers contributing to real science here.
That's right. That's right. That's amazing. Yeah, Pro-Am collaborations are some of the most exciting things that amateur astronomers can do. And it's great to see this happen right in front of our eyes. This is...
Yeah. I was surprised because, after I talk, I think about a minute after, I see this message that this thing has happened. And I was looking at it. I imaged this region a few days ago, and there was nothing there. So this is just an instant where you have a discovery happening live. And I think professional astronomers are going to go over this one. Hopefully, we're going to have some Hubble time to image this storm.
Yes, that's awesome. Thank you very much for sharing that. Thank you.
You're welcome.
All right. So Dustin Gibson, it's time to meet back up with my good friend, the captain of OPT, and sharing his universe on Gibson Picks. So how's your week gone so far?
It's been crazy, man. I've been quiet here because I think I may have broken my audio. Is it skipping at all?
No, it's good. It's all good.
Okay. So I had to take it off the other mic and go back to this one because, growing up in Alabama, we kind of figured out, if you can't fix it with a hammer, it's not worth fixing. But my computer doesn't respond as well as most things do. So I seem to have really messed up my audio for things. But hey, man, can't win them all. Feeling pretty good about that.
Sounds as good as it ever did. So
okay, well, good. But yeah, man, it's been super busy. Things for the entire astronomy community. It feels like, we get this really unique perspective where we get to see kind of globally what's happening in the amateur and professional spaces.
Mhm.
And I think both right now, there's more momentum than I've ever seen ever in astronomy, on both sides. The professionals, it's like discovery after discovery. And then because of Elon Musk, forcing this rapid evolution of the privatization of space, now all of these communities like the SSA, Space Situational Awareness communities, have all of this new government funding, not just in the United States, but all over the world, because space junk now is more important than it's ever been.
Mhm.
And, they have to know, where are these problems that are circling the Earth at 18,000 miles an hour that could take down a rocket or take down a very expensive satellite.
It hasn't already happened, frankly. I mean,
It's amazing.
Yeah, there's just all this stuff flying through. They must be just tracking it to an unbelievable degree and going, okay, there's your window, go for it. So,
well, what's scary is that, so when we do a lot of work with the SSA companies, and so they'll call, and the plan's always, we're going to build 100 observatories around the world, and we're going to track every single piece of things we can find.
yeah,
But in the conversations, we always talk about, well, what's your resolution? What's the target? What are we trying to find exactly? Because they can find if a solar panel comes unhinged, you can find that pretty easily. But the problem is even tiny things in space. I mean, something, half the size of a penny in space moving at that speed will just absolutely devastate something. And so they're having to get bigger and bigger scopes with better and better, more sensitive cameras. And so these systems are becoming extremely elaborate, but they're getting very good at it. I mean, they're finding things that are smaller than a bolt, at this point. So they're starting to track it all down. But the problem is there's new stuff every day.
yeah. Hamandis 87 said flecks of paint even they're tracking.
Oh, you have to. Yeah, you have to. I mean, anything. Think about the James Webb, right? And
Yeah.
so, it's going out far enough where it should be pretty safe. But think about on its way there after all of this and everybody giving NASA such a hard time for this insane delay and the money that goes into it. And then it's on the way there. And as you mentioned, like, a piece of paint, a flake of paint hitting that thing at that velocity is just like, it's terrifying. Yeah, it's terrifying. But that's, on the pro side, we're seeing a lot of that. And, Elon is just, I mean, that guy's unstoppable.
Yeah.
And so he's going to just keep going and going, and he's making it possible for everyone else to. Even, we're invested in a satellite company, Space Fab. One of our ex-employees built a satellite company. And even that was never possible before Elon's projects, before SpaceX, because now it's affordable, relatively affordable to get things in space to companies that before, there was no startup that was going to put something into space, right?
Yeah.
But now it's happening all the time. And so it's really, really exciting on the pro side of things. And I think it's just going to get better and better. But this is how you see exponential growth of interest and industry, because you get more people interested by access, and then when those more people get interested, innovation follows, right? And so it's fascinating watching it happen. And the same exact thing is happening on the consumer side, on the amateur side, and social media and all of these vehicles that have now kind of coalesced into this machine, this ability for people like Jason and Christopher and on and on. I mean, we see so many of them here that can reach out and, touch thousands of people with a single image. I mean, Jason, you post something, 20,000 people are going to see your image that day, you know? And
Yeah.
so you can communicate a space message better than ever right now. And all of this stuff is forming these positive feedback loops of excitement and productivity in an industry that we all share a love for. I think it's the most exciting time ever.
I think for me, I think it's a rebirth, or it's like we're repeating history where it's, 60 years ago it was the government. Now it's commercial and consumer and commercial space activity. It's a new rebirth to like what we experienced, Scott and I experienced, and others in the 1960s and 70s. It's the same kind of thing.
Yep, that's right.
You
That's
know,
right. We're in
Go
a
ahead.
golden age of astronomy. We really are. We're all lucky to be alive, to see it and to experience it, because every day there's some amazing discovery, some breakthrough, some amazing thing is either uncovered, discovered, imaged, reassessed, to be a real working professional scientist today and to keep up with the bleeding edge of what's going on. I can only imagine that you're throwing out tons of old ideas that were benchmarks, that are having to be reworked. And as a cosmologist, Marcello, just with every new discovery, it's got to add to, that model of what is our reality? How do we get here? Where are we going? What is ultimately going to happen with the universe? Will it evolve again and again? Are there multiverses? Are there, so it's just an amazing time to be alive. It really is. And astronomy being the gateway science that it is, any of you out there watching this show right now, no matter if you're just a casual stargazer or you're deep into amateur astronomy or you do pro-am projects, or if you're a professional, it's just the best time ever to be engaged. So yeah.
We talk about that all the time on the Space Junk podcast. Actually, this is the first time I've seen Chris go since the Space Junk podcast we recorded in the studio. They're so good to see you, Chris. He's one of the living legends in the world for planetary photography. Every time I see his stuff, I'm like, I'm never shooting Planetary, because he's already beat that. That's done because Christopher Go attacked it, so it's already so good. But we talk about it all the time, how this line has been blurred between, like you just used the word professional, right? And so that's astronomer with a capital A. But that line has been blurred so much now. I mean, I'm wearing a shirt right now from some of our team, Asteroid Hunters, which if you guys aren't following, by the way, I would correct that mistake immediately, because they are absolutely incredible at what they're doing. But this is a father and son duo that is now actually in their backyard doing real science and contributing in meaningful ways. And, they're also educating on science. And this is, when you're doing it with, like I just described, that vehicle, now you're taking information that for, at one time was so esoteric. It was just for a handful of people that had an interest, deep enough to go spend their lives researching. But now you can have a father-son combo in their backyard, be taking pictures of asteroids and explaining the process and, getting this stuff scientifically validated and communicating it to the masses in a way that's actually, understandable. And, I don't want to say that it's not interesting stuff, because it is, but I think that the way it was communicated for so long in the academic space made it very hard for people attached to, because it felt detached from a day-to-day reality. It's like, well, how does that affect me? Right. But that's what it allows you to do when it's somebody that's just a father-son combo communicating this stuff. And that's why I'm just saying, like, everything right now is primed for that reality to set in to the general public, that this is the only time that we've ever been able to say we can explore our own universe. We are the only living humans that, that could ever say that. We can do it in a way that's like, I can go in my backyard and see right now in higher resolution than anybody that came before me ever did, because of the tools available to us and the technology available to us. And I can do it on budgets that are laughable to scientists, that have had, look 10 years back, Scott, you remember what CCDs were costing? You wanted to get something full frame?
Yeah, they were a fortune.
Oh, it's so much, man. It's like, all right, I'll get one, but I got to sell my house first.
Right.
Now it's like you go get full frame cameras for a couple grand.
That I remember going to Palomar and seeing the 4-shooter that Jerry Neugebauer had designed, and it was 4 CCDs that were stitched together so they could have a decent sized chip for the 2 inch. And this was millions of dollars for this.
Yeah.
Today it's probably sitting off to the side, in a pile of other instruments. But
I think Dustin brings up a good point with we talk about it a lot with personal discovery. And that's what this journey is about. It's not just a national discovery, and when we learn new things and brand new stuff, but when you go out and observe the universe, you make the same observations that scientists have made, or that other people that do imaging, great imaging, like Jason, and you personally discover, oh, look at that star there. That's something new. I haven't seen that before, So you personally discover everything in the universe, just like everybody else that observes.
That's very
true. And I always refer to people as or in the community as astronomers. I try to not say professional, or actually I try not to say amateur so much anymore. So it's just astronomer. We're all astronomers.
Yeah, and that's why we love you, Jerry. Because that's right, man. That is right. It's like, why do we need to, if it's not for ego, why else would we need to have people distinguish themselves as amateur? In what other space do we do that? If somebody just has an interest and they're actually doing it, right? A painter is only a painter while they have a paintbrush in hand. And other than that, it's like, I feel like there's nobody there's going to be like, oh, so you didn't, how much time have you spent? You're an amateur painter. I need you to say that when you speak to me. Like, why would we do that? If you have an interest in astronomy and this is something you're spending your time doing, and especially now that it's possible to contribute to scientific data, that designation is not only inappropriate, it does a disservice to the entire community.
Well, sometimes amateur has a negative connotation, like you're not very good at it or something,
Well, yeah, and that's exactly what I mean.
Yeah, sure.
Yeah, it's not to take away from anyone else, but it is to lift the entire community up. I respect, the academic world. I've spent 11 years in college myself, right? It's just, I do also know that there are ways to learn things other than sitting in a university. And what I always found is university measured my discipline more than it did my intellect. That was the hard part for me, was just showing up and, being present. But I think that it's just right now, the entire world for astronomy is open to anybody to contribute and participate in at whatever level they choose to, from what we would have called amateur all the way up to the most professional space. And I absolutely love that, because it should be inclusive, and it is now. And I think all of these vehicles are moving in that same direction.
Yes. Yeah. Excellent. Excellent. I love the way you put things, Dustin. You're very eloquent, and you were definitely on the mark, so. And
that's what Alabama's known for, right?
That's right. That's great. That's great. So, I'm looking at the wall here, and we've got Gary Palmer here, kind of sinking back in his chair a little bit. How are you feeling there, Gary?
It's all good here, Scott.
Yeah.
Yeah. It's nice and relaxed and chilled out. Skies are a bit cloudy, high cloud coming in. So yeah, it's all good. Enjoying the show, enjoying the guests on there tonight.
Yeah, we're glad that you're hanging out with us. So anything that you wanted to share with us tonight at all, or are you just hanging?
Yeah, I think really I wanted to keep things quite simple. What I wanted to do was look at what we could get on a budget.
Okay.
Because quite a lot of us are experienced, and if we all chuck down our equipment on the table here, there would be quite a lot of money spent. And I thought, let's have a look at what we can do on a little bit of a budget. So I've just put together some images from this week. Yeah, really what we've been playing around with. And I have to say the weather has been really, really poor here. Seeing conditions have been quite bad. So we've been playing around with the iExos 100 and the Exos 200 mount this week, just on some solar and some planetary stuff. So if I share the screen up, I just put a couple of images in some folders. This I was actually quite impressed with. I'm hoping you can see that there.
We can see it.
This is off of a 102mm telescope, RGB, and it was just 1,000 frames captured for each filter and then put together. Now, considering how bad our weather is here and the aperture of the telescope, really we're taking images like this for around, if you include the mount, somewhere around the £700–800 mark, yeah, with a camera. And this is sort of some of the setups we've had running this week. This was a little bit out of the ordinary. There was a little bit something we were just trying out and testing weights. So we did put the 10-inch Casa grain onto the Exos 2.
That's interesting. Look at that.
Yeah, it took it and it imaged one of the images here. Let me go back to that one there. That was taken on it. That's a 2-panel mosaic that was put together earlier this evening. And it's not even finished in Photoshop or anything. It's just literally the mosaics put together. We've had solar running this week. So the little 100's been doing solar with the Quark. That's been working quite well. So that produced this image, yeah, earlier today.
Wow.
Same setup, everything on it. So 18mm, standard Quark on there, running on the iExos 100. So again, budget mount, really quite a small telescope, small aperture on everything, but we're getting in quite close to the sun, which was quite nice. The Mars shot was taken on the 102, as I said. That was done last night. Again, it's all been basic equipment this week, and we've had some fairly reasonable stuff out of it. So again, the mosaic was just literally a quick throw together. Just put it into Microsoft Ice, stitched it together, cropped it up, yeah, and then exported it out, and then sent it straight into a still image. So we've not even done any real processing on that at all. I'm
really impressed with that Mars shot, though. That's really nice.
I am just for the aperture. You know, if you actually saw what I was imaging in on that, I did try Saturn on the Cassegrain, and I was actually getting 2 Saturns. The atmosphere was that unstable. I had 2 Saturns bouncing around in the image, so it was just take the scope down and put a smaller telescope up. So for a nice, simple, reasonable image. Tonight's moon, I did that a little bit earlier. That was using the APM 107, and we used the Explore Scientific 7MP camera on that, and that worked out quite well. And another one there, again from last night. So we've been getting a few bits here and there. Let me just see what I've got open in there. So we could just do a quick basic process on this, drop it into here, split the channels again. This is just to get rid of the green. And then we're just going to do a quick linear fit to balance the colors out. So we just go to the green channel, select that, drop it on the blue, and then drop it on the red channel. And then we're just combining back up. So channel combination.
Image processing demonstration. If someone is as good at it as you are.
At warp speed.
At warp speed, that's right.
There you go. So now what we need to do is bring the color back out in it a little bit. So just go to curves transformation, select the image, put a live view up, and then go to saturation. Just bring a little bit of saturation into it, a little bit of color back out. And just do a little bit reduced on that. And this isn't even really sharpened or anything, it's just as is at the moment. So that would be our final image, and then we could brighten it up and contrast it a little bit and go from there. So it's nice and straightforward. But that's really all I've been working on this week. It's all been that sort of stuff. I've not managed to process the image from Friday's star party yet. Hopefully we'll get that done over the next few days.
Right.
Data look pretty reasonable from that.
Right.
So that's it from this side.
So we are planning on another European edition of the Global Star Party. Gary's already talking about going from like Norway down to Australia or something like that. So
I think that'd be good fun. I think if we actually start imaging somewhere over in the other side of Europe, and then we can continue it through the UK, and people can drop off once they're finished, and it can run through the US and start running down and see how far we can go with it in a short amount of time.
Right. Yeah.
It'll probably cloud out in both hemispheres all over and pour with rain. And but the idea is there to have a bit of fun. Yeah, and just see who we can get involved in it.
That's true. That's true. And
but the next European one, I think we're looking at the 11th. Yep. And we've got quite a few people. Grant's on about bringing the observatory in Spain on. Pranvera's on about coming on and discussing some of the stuff she's doing at the moment.
Australia right now. That's right.
Yeah. I think she's back in California now. So
she was
back now, but she's doing some work on the remote observatories and some other bits. So she's looking at coming on, and we're talking with a few more people at the moment.
Beautiful. That's great. Okay, so let's go back down to Argentina, where Cesar Brolo is waiting for us. Cesar, we had a little bit of trouble getting back on, but
yes,
we're very happy. So, and so what can you share today?
Well, we can talk about a little of optics, how normally we talk with the people about to ask about the capacity of the telescopes and the fragility that how the telescope can modulate the wavefronts that coming from very, very far away place in the space.
Sure.
And I can show you first of all a small video of a little experiment that I'm making again. Let me check. First of all, I show you a short video where I am polishing 8 inches mirror, and this is why optics are for astronomy are so difficult to obtain. The people think sometimes that it is the same. Is the same if it's the same type of optics. The industry of astronomy. This is my Draper machine. Actually, it's a Draper machine that I have from my 16 years old. My father.
Oh wow!
Yes, this is the part of my history in optics. Well, I turned the cell phone was my
And you got
mistake.
when you were 16 years old, is that right?
Really, yes. I worked the entire summer to buy the parts.
Yeah.
My father say, okay, you like, I can make, my father actually, he have 83 years old, and he's a specialist in make machines. He is from the mechanical industry, and this machine is a Draper machine that have two different eccentrics to polish glasses, mirror glasses. And actually, I make the last of the grinding, and I go into to polish. And next how do you say? Next project is put 28, 10, yes, a 12 inches mirror. And something that normally I need to talk with the people about how industry in astronomy optics is that is not for only, let me check this. Well, vamos a dejarle. Is different to the industry of astronomy optics, like optics for glasses, where do you have maybe the high error that you can have in a glasses, you can have an excellent ophthalmic glasses with an error of maybe 10 or 100 part of a millimeter. Sorry that I don't talk in inches. You might have more millimeters, the metric system.
Fine.
But of course, in comparing with medium quality astronomy optics is more than a part of one thousand part of a millimeters. Is so different. That is sometimes is difficult to us show how we can explain to the people why you can don't use a single system of ophthalmic lens that have, for example, 1 meter or half meter of focal distance, and the people say, okay, I can make a telescope with this. Okay, you can try. And when they put in a tube an ophthalmic, good quality ophthalmic lenses in maybe half meter, that is two diopters, similar that you can use for reading glasses, and they expect that they can get the same quality image that in a regular telescope. And when they discover that it's unable to have an image from a regular lens from the industry, ophthalmic industry, they start to understand that the precision that do you need for astronomy optics is really high. It's really a lot of time more precise, that regular ophthalmic glass. But in the middle, some people say, okay, I have a Leica, or I have, I don't know, Icon, and sometimes I explain that, okay, the lenses are excellent, but sometimes are not so precise like the surface that are made to be an objectives of a telescopes.
I see. So how long have you been polishing optics for telescopes, Marcello? Or not Marcello, Caesar, sorry.
Sorry, okay. Well, I start to polish or to make mirrors for me, not for sale, or for my experiments from the 16 years old. And if you ask me, sorry, how many time have polishing, for example, 8 inches?
Yeah.
Normally, do you need for cerium oxido, that is the typical with a maybe the best is 20 hours.
Oh, wow.
But you have, yes, I for me ever was different the time, because sometimes it's between 15 to 20 25, because changing some condition of temperature or humid, you have a different effect of the how the polishing is or when the polish is ready, because it's something that you can get the totality at the totally time perfectly. This is the problem why the people say, okay, you don't have more telescope. That is the problem is now. And for me, it's not a surprise that, for example, if the manufacturers in China, for example, they stopped maybe 15 days, in our industry, in telescopes, it's a disaster, because it's an industry that is very, very small quantity to make. Is very difficult to make each piece of a mirror or a lens for an objective. You can not make something in series, and something like I don't know, make well, I don't have in my mind now, but many things you can make the machine, and the machine can live maybe 100 in 1 minute. Well, this is not the reality for optics, especially astronomy optics. In ophthalmic optics, you today made by something like casting. It's not really casting, but it's similar. But for astronomic optics, you need a really process that you cannot live outside of the line of production. And it's one of the things that and normally I use to explain something like the size of let me check if I have a small presentation with a table of the size. Sometimes I give to the people the idea of who is the size of a planet or especially small planets in a telescope, because normally we talk in small angles. For us it's easy, but to understand some fragility of the telescope that need to be very static, pointing to the star or a planet. Normally, I talk with the people that, for example, say, okay, your image of Jupiter, for example, have maybe in your telescope 3 millimeters. So the people say, what?
So tiny.
Yes.
Yeah, they are expecting it to look really big, right?
Yes, and before I explain that, the magnification of the eyepiece is that make the entire miracle. But first of all, the things are that you need to have a stable mechanics, air in the atmosphere, or the people start to understand how fragile is their telescopes.
Yes. Yeah, and how precise they are. It is amazing that that telescopes sell for the prices that they do. The last time you were
absolutely
on, Cesar, you were talking about just the amazing low prices of precision optical telescopes, and it is absolutely true. That it is such a bargain because the amount of effort that it takes for someone like you. I mean, you have made telescope optics. It is a lot of work. It is a lot
of work. Absolutely. If I can, yes. If I need to put a price of this, for me is entirely a passion.
Yeah.
But it's impossible to calculate because you have a lot of hours. If you need 24 hours only for polishing in a mirror, maybe in the industry, you can start to make more faster because you can use a diamond system where you can ring the curve of the mirror to start more fast. But you need maybe from 10 or maybe 30 hours of polishing, and you can't make something magical to have at least at today something. Well, I remember your video where you show the draper machine in the factory.
Yes.
And these machines, the first of all that you can see is that work at no more than maybe 30 RPM. And this is the typical velocity in astronomy optics. This is why the people say, okay, it's a miracle that I listened to Dustin talking about we live in a miracle age where we have more affordable things that we never expect. This it's incredible, and it's so hard and so complicated make an astronomy surface optics. Sorry that I mixed the words, but they're so different to the rest. They're different to the photography industry, photo industry. They are different to the ophthalmic industry because the the typical error of a lambda, so the long wave of where you take 550 nanometers and you say, okay, I need the 8th part of the maximum error for my. So this is so difficult to obtain, and is something that the industry today can give you. And maybe in the 1965, the industry was unable to give you this quality and this price. If you had in the 70s a telescope with the precision that today you can get, maybe the price in the 70s was, well, I listened the same that you talk about this. Dustin say the same. It's so incredible, the difference.
Yes.
We are living in a golden age about astronomy, and I think that we are in a new space race. That, well, in my country, we have 2 satellites that was launched by SpaceX. The last one was this weekend, and the Saucon 1B. The Saucon 1A was launched in 2018, and now it's the second one, and together make something like a constellation of satellites. And this is the I listened just to Dustin, that for me, I think the same. I share the vision of the SpaceX put the reality of a new space era, space age, in a level that we never expect, that is so fast and so strong, the changes.
Right. I agree. Okay. Well, thank you, Caesar. Thanks.
It was a pleasure. I have my Exos 100, but come on, today is cloudy. It's raining in Buenos Aires now.
So
I can give you any image tonight.
Next time.
Yes, next time I prepare this.
That's
yes, with this setup.
So let's go to the Astro Beard. Richard Grace, how you doing, Richard?
Not too bad. How's everybody doing tonight?
Yeah, it's all good. It's all good.
Thanks for coming out to the party.
Mission control there.
Yeah, man, I got a few extra screens going on tonight. Actually, was something I wanted to show was my portable power system. So I'm going to change cameras.
Okay.
All right. Let's see. Now I got to face the other way and make sure the microphone still works. So I'm going to try and use a laser pointer here.
Okay.
Hopefully it doesn't blow out the camera. But essentially, if you can, yes, you can see all the large blue things in the bottom. Those are individual lithium iron phosphate cells, 90 amp hours each.
Wow.
8 of them total, which adds up to 180 amp hours of 12 volt equivalents. I like to go camping for about 17 days at a time when I go for 3 weekends in a row. So we use this to recharge the electric chainsaw and way more than astrophotography gear. We have worldwide HF communications, VHF communications, charging docks for the small radios. Over here on this side, we have a MPPT charge controller. We're turning the 12 volt here into 19 volt with a little DC boost converter, and we're using that to power the Dell box back here, which is actually a Thunderbolt 3 interface to the laptop. So it is one wire into the laptop, and you can run your other USB cable to your camera and everything. So, I mean, I guess it all depends on, you know, how you're doing. If you're automating, you're probably not going out camping and automating too much, but I have no idea because I'm still pretty new at this.
Also, and be automated from anywhere.
Yes, absolutely. We've got a massive GoPro effect happening with the camera angle here, but essentially this is all put into a 42-inch like Pelican double rifle or carbine case, which was basically the width of the back of the Trans Am. So I built all of this within my own dimensions, but you know, anybody could do pretty much anything like this. And in the days of people doing a lot of you know, ride along Raspberry Pis and stuff, this is kind of the opposite approach. You know, bring a table, throw this next to your scope, or in my case, put it in a 8-man tent that has a wood stove jack, and you know, go for a few days and do my thing. So I just wanted to show that. And I guess real quick here, let's change back to the this camera.
This kind of highlights something I've talked about quite a bit over the years, Scott, is that not just amateur astronomers, but a lot of people are become system integrators now. We have such a wide range of products to buy from manufacturers all over the world that we become system integrators to build up our specific systems for our application. In terms of astronomy, that's a big part of the deal. But I think we're starting to move. Well, as a company, we're trying to move a little bit beyond that to provide turnkey products that are highly integrated systems like this, I think.
I'm going to share my screen if that's all right.
Sure.
Should be sharing. Do we have a picture of Andromeda? Yes, we do.
Yes, you do.
Okay. This was just a test image. I wanted to see if I messed up the alignment of my triplet, which I did. But it still turned out pretty good for some test footage, the best that I've done thus far. And I want to thank Gary for showing me what I could do with some of the other the other data that I had. And I spent a little extra time on this one, and it turned out really good.
Beautiful.
I did end up with a little bit of blue on some sides of things and changing, but that'll be all fixed up soon here. And I just wanted to show that because that's pretty much all I've got for the night. I am clouded out, but I'll be hanging around for the party.
It's a beautiful Andromeda galaxy you got going on there. So you're working a little bit with Gary.
We sent a couple emails back and forth. I think at some point we're probably going to do a Skype call or something like that. I'm not sure yet.
Very cool. All right. Well, I know that one of our customer service reps here, Tyler Bowman, is anxious to start working with Gary to learn more about image processing so he can take his astrophotography to the next level. So that's really great. Let's jump over to 100-hour Wade. And you are muted.
How about now?
That's all good.
Hey, how are y'all doing?
We're good.
Well, I feel a little out of place here with all these professionals. So
you're doing pretty well yourself, Wade. Your images are incredible, and I watched a bit of your show on Twitch. And you're running a great show too.
Awesome. Thank you very much.
Mm-hmm.
Yeah. You know, I'm still, you know, I've only been really doing this for about 6 months. So I'm still new at it, and I'm just, you know, trying to help out, you know, everyone else out there that's new, that's, you know, found it, you know, tough to get into it and to get results. So, yeah, that's pretty much what the, you know, that my part for the Clear Skies Network is. So, yeah, I was just gonna, you know, tonight, we got rain all of a sudden. You know, I have a friend that's that is a, meteorologist here in the area on one of the news channels. And me and him, we're gonna have a chat. Cause, This guessing game with the weather, man, is killing me.
Yeah.
So,
Yeah. Now, one of the guys that was watching earlier, his name is Dan Scoff. Dan actually made a video for us. So to teach amateur astronomers how to really judge the weather like a professional meteorologist does. So I will run that video again, not tonight, but in the future I'll run it on one of our shows, and you can watch it. I think it is also up on Facebook, and you could rewatch it when you want to, because he gives you the mother load of information and sites and ways to look at the data so that you can predict weather. So it's
that's awesome.
Yeah.
Like the rock hanging from the post. If the rock's wet, it's raining.
That was some of the early instrumentation of the meteorologist. Yes. But and maybe still some of the best. That's right. Go outside. Is it hot? Yes. Okay. Mm-hmm. That's right. Well, great. Anything to share with us at this time, Wade? Or
yeah, I was going to. So I actually got a. Let's see. I'm going to transition over to this. So here's my this Explorer Scientific IXOS 100. This is pretty close to the setup that that I've been using lately, and I just want to point out again, if you're looking for something small and light that you can throw in a backpack, and those the star trackers have caught your eye, I'd really I'd really ask you to give this a look. The price is very similar. It comes with, pretty much everything you need to use it. It comes with a tripod. It comes with, the counter weights and everything. And so this thing, but it gives you that deck motor also, not just the RA motor, but the deck motor. So you can use it with a computer and allow the computer to fully control it. There's no guessing for us new guys where something is in the sky. You can plate solve to align to find that. So so this is a great telescope mount.
Now, what kind of this is a camera lens that you have your ZWO attached to? Is that right?
This is the Space Cat. This is that William Optic Space Cat.
I see. It looks like a camera. It looks like a.
It does.
LR camera lens.
Very similar. And if you were lucky enough to get the Night Cat, it's all it's a cool black on black. So it will definitely look like a lens sitting up there, telescope lens.
Very cool.
So but yeah, we've got that's the 533 up there on it, the ASI 533, and
okay,
some other stuff. So so it's a great setup to take out, and I use it with the ASI Air Pro, and I can I'll even show you. This is kind of cool. I have my iPad here. If you can see that, and you can still see the camera in there, but I can select a target. Let's see. I'll go to this is the North America that I'd been shooting, and and just hit go to, and that bad boy will start moving,
and away
away it goes. And what it'll do is once it gets there, it'll actually take a photo, and it'll plate solve that photo and learn how far off it is from the actual target, and it'll make the adjustments and then re-slew to it, and it'll do that once or twice, but usually before, and it'll be dead center of that target. So
awesome.
So just a really awesome tool to use.
Hey Wade.
Yes, sir.
Since I've corrected that one issue with the firmware with it missing the target when you did a short slew, have you found it working good for you now?
Yes. Now, look, honestly, with mine, it was not that far off. So I mean, that wasn't even really, a real concern for me on there. I mean, it was already very close. It's very minute adjustments that it makes when it syncs. So
Okay, good.
yeah,
I
so
just-
it's done a great job with, as long as I'm, have a pretty good polar alignment, I'm level and I have a pretty good polar alignment, it'll come really close to the actual target you're looking for. So
That's good.
and then so that's pretty much that. And then the one other thing I wanted to show was so I'm going to bring this up. This is this image I took. This was one of the very first deep sky images. This was the second. So I took one the night before. And no, I'm sorry. This is my first. That's absolutely wrong. This is the first image I ever took.
Okay.
And I tried to process it. So
I don't think
this
your screen,
I'm sorry.
Wade. I don't believe you're sharing your screen.
Oh, here we go. How about now?
There we go.
All right. So this is the first image I ever took of a deep sky object. It's Orion, of course. It's the pretty much the easiest one for new hobbyists to find. And so I was able to get this. And now I took another one on the second night. The only difference is I used a focal reducer on it. So this was at 2350 millimeter. And the next one I'm going to show you is at 1645 millimeters. So that's the only difference. But the difference is I processed this after I took it. This is as good as I could get it with the limited amount of knowledge that I had. The next one is I processed in about 3 months later, and after working with a ton of people, Dustin and him starting the Twitch stream was just a huge just a huge breakthrough for me in doing this, getting real-time answers from people and getting real-time help. But I just wanted to show everyone out there that's new to this. This is where I started from. And 3 months later, this is pretty much would have looked the same if I would have processed it that day. It's just that focal reducer. But this is that image.
What?
Same camera, same scope, just a focal reducer.
Wow.
So that's that is just, so my point in all this is stick with it. Stick with this and, keep learning because, you can do this. You can be very successful at this. And that's really what I wanted to share tonight.
Thanks for sharing that.
It's all about your skills and knowledge. It's not about your equipment.
Right.
I've always said that.
So, and again, this is not with an Astrocam. This is a Nikon D750. It's a stock camera this is what we had. My wife is a photographer. And so I liberated her camera from her and hooked it up to my telescope and and started using it. So so this is so you can start. You don't have to start with the most expensive stuff. And in fact, I actually owned this telescope for a year before I could take this image. I bought too much scope, right? I watched these YouTube videos of these awesome guys doing this, and I thought, oh, I'm going to run out and do that right away. And I bought this super expensive equipment and just got lost in it, and really what probably would have been better was if I would have just got that IXOS 100 and used, my camera and lens, with it for that year. I think I would have gained I'd be ahead of where I am now, so just use, you can use what you have, going back to what Jason was talking about,
You're
earlier.
pretty far ahead right now. 100-hour Wade. I mean,
How much?
pretty amazing.
Thank you very much. Appreciate that.
I don't know. So that's
anyway,
that is excellent.
Well, Scott, we're bumping up against my bedtime, man. I've got super early meetings in the morning, so I've got to dive out. But real quick, I just wanted to say thank you to everybody here, you know, putting in the time on both sides, just watching the channel and then also participating. It's so very appreciated. Scott and I talk about this all the time on the phone, just how dedicated everyone is and the contributions and how much they mean, because it hasn't always been the case that things like this have happened. So truly, thank you so much for doing it. And thank you for doing it here on Clear Skies Network.
Absolutely. Thank you for letting us be on Clear Skies Network.
No, so glad to see it. That's what this is about. And, you know, the panels here are always incredible. It's every time we pop in, it's intimidating seeing everybody here. Like, man, just gets better and better. It's better and better. So,
right.
Yeah, just wanted to say a quick thank you. But I'll be back on Thursday for my Twitch crew. But again, thanks everybody, and I'll see you next time.
For hanging out. Take care, man.
Thanks, Dustin.
Okay, so our next guy that we're going to is Simon Tang.
Hey, Scott, I'm sorry to interrupt you. I don't know if you want to do another question before we get, because we have 3 questions.
All right, so we did 2 already, right? So
no, we did 1.
We did 1. Okay, all right.
I think that's all we've done.
Let's do question number 2 then. So question number 2 is going to the prize will be a Galileo scope, which I happen to have right here. Here, I got, let me put the camera on myself. There we go. Galileo scope, which is the telescope kit developed for the International Year of Astronomy, 2009 International Year of Astronomy. It has been used as an educational tool for hundreds of thousands of kids, maybe millions of kids around the world. You'll once you assemble one of these, you'll know how an eyepiece works. You'll know how an objective lens works. You'll know how the whole telescope itself actually operates. It's got a 1/4 thread on the bottom. You align it by gun sighting. It's like gun sights up on top of it, and you just sight right along the tube like that, and to check out things like the moon, Saturn, and Jupiter. So this the prize will be this telescope and a 52-degree eyepiece of your choice. So what's question number?
Well, you want to send the questions to Kent at explorescientific.com. Kent, right?
Kent, you don't want to answer it here on the chat, but you want to send it here. Scientific.com. There you go. And you need to join the Explore Alliance, at least as a legacy member. Legacy membership is free. And I'll put down the website for that.
What a bargain.
I know.
But you get some, what else do you get with that membership though, Scott? Don't you get something?
Oh, you get the opportunity, first off, to be involved in all the other prizes that we have. You get if you have not registered your products, you can get in and get your products registered, so you have some protection on your product. If you want better protection, we have it. Okay, we have something called Alliance Care, and Alliance Care at its best in our $100 package will give you a $100 gift certificate, which you could spend back with your dealer or with us for Explore Scientific gear. You then have something called advanced product replacement. Okay, so let's just say that
that's basically free product replacement because you get your $100 back.
Yeah, that's well, you get $100 back. But let's just say that you're out observing and somebody runs over your telescope, okay, and you want to go to, you're heading down to Australia and you want to have another telescope right away. We will in advance send you a replacement telescope, okay? In the continental United States, we do this. If you are an international person, you want to do this type of thing, you have to have a way to get it to you, okay? So a lot of people have channels like that. But we do replace the product, and you know, it really makes it worry free, you know, is the main thing. So and that's at the $100 level. At the $30 level, again, you get a $30 gift certificate. It costs you nothing, and you still have all of your product with the no fault warranty. So not advanced product replacement, but no fault, which is nice.
That's nice. Yes.
Yep.
All right. So the question is, how many minor planets have been visited by spacecraft? How many minor planets have been visited by spacecraft?
That's an excellent question. Okay.
Yep.
All right. While you guys are trying to figure this out, we're going to bring on Simon Tane. Simon, are you? I see his telescope working here. There he is. There he is. Simon, how are you?
I'm good. Can you guys hear me?
Yes.
Excellent. So I've got one heck of a setup, not from a telescope standpoint, because obviously you guys can see it, but it's the ability to jump between multiple cameras, which is probably something that you guys haven't seen yet.
Oh.
I am literally looking at Jupiter right now, and funny enough, I can actually just press a button and it just goes to it.
That's cool.
So you guys can see it, so I don't have to always do the screen share. So seeing is actually pretty damn good right now.
Yeah.
It's swimming.
Yeah, it is a little bit off the Ripley side. So it was actually really, really solid earlier on, but I don't know if Chris saw my message, but I was asking him if we can actually see the storm, because this is what I just got a few seconds ago. So I don't know if this is the storm that he's talking about. Chris, you still there?
Yeah, I'm here. What time was that image taken?
Literally 15 minutes ago.
What time is it now, UT?
Well, it's 10:10 p.m. my time.
Let me check.
So universal
15 minutes
time.
ago, it has already moved out because it was captured at 2 o'clock UT.
Oh, okay. So I'm probably not even looking at it then.
It's 4 o'clock UT right now. 4:10, isn't it? 5:10. 5:10 UT right now.
2 hours ago, so it must have moved.
Oh, okay. Well, I tried.
You missed it, but that image wasn't that bad. It's actually quite good.
No, I mean it turned out pretty good. I mean, my scope is not brilliantly aligned, so the planet keeps wandering off. I kind of had to slap everything together, because with all the wiring and all that kind of stuff, so you can kind of see my scope is there. I had to run off and do a meridian flip, so I didn't even bother to do an alignment. I just did the meridian flip and just started doing stuff, you know, like I always do. I never align my scope.
Well, that's great though. But I love your setup there with the multi-camera. You know, that's slick.
Oh yeah, so I can just literally just jump around. I mean, it's weird when I do that because it just tiles off to infinity, but
right.
You can kind of see what's going on. And I have like a fancy camera here, so I probably look a lot clearer than usual.
Yeah, no, that's good. You got good lighting. You got, yeah, as far as somebody making a presentation for, this kind of global star party, you're doing, you're hitting on all pistons, I think. So that's really cool.
Well,
that's
I mean,
really cool.
You know, the funny thing here is though, when I was at the store, that was the biggest thing that people missed, was seeing the equipment, seeing the setup, seeing the scopes, and seeing all the different things through the telescope. So I thought, you know what, it's really just a lot of us just sitting around on a computer screen, and people don't get the idea of it. But when you get to see an actual telescope in action,
Yeah.
There's something about it that feels really cool. I mean, if I can reach across without knocking everything out of the way, you can actually see I actually have my green laser, because everybody loves green lasers.
Yeah, right.
And it basically is pointing at Jupiter, essentially. So you can get an idea for it. I mean, that's the whole point. The idea of a star party is to allow people to experience, you know, space and astronomy in ways that they've never thought was possible. And I kind of like this method of doing it like this, because it's like an electronic version of the whole thing, or what's more commonly known as EAA, electronic assisted astronomy.
Yes.
And it's become so popular, and you can do this from home.
That's right. That's right. You know, and a lot of people that are involved in educational outreach, you know, people that might have been sidewalk astronomers, you know, or, you know, who did, you know, grand outreach programs. They're now, especially in this time with COVID, they are looking at electronically assisted astronomy quite a bit. You know, how can I get panel up? How can I share this experience? You know, so we're all looking for ways to get around and to show and to share.
Well, I mean, even if we could have parties again, and instead of having people come up and touch the eyepiece and things like that, with EAA, it allows people to physically be there in person and still see things. I mean, I know a lot of traditional astronomers who do a lot of visual don't like all the light pollution and having you know, white lights turned on everywhere. But you know, sometimes technology has gotten to the point where we have to do something in order to please the crowd. So having this kind of a setup, I mean, if people on the streets could see me right now, I mean, they'll be swarming all over me right now, but it'll be done in such a fashion where it's safe, so people can actually see the screen and see what's going on.
Yes. Yes. It's fantastic.
I think people also like to see when you click on your planetarium program at an object, say, I'm going to go to this object, and they see this, you click on it and they see the scope move like it's magic. You know, the first time you see a scope slew from a computer, the people that aren't familiar with it, it's pretty neat for them. I think I get that all the time when I was showing people how you could use a computer to point the telescope.
Oh, totally. Oh, totally. I mean, it's like, if I ever want to attract attention, even when I was doing outreaches, the minute I pull out that green laser, people just swarm in from nowhere, you know, because they see that green line that just runs out into the sky. And then, you know, I'll always like say to people, it's like, oh, what do you want to check out? I mean, we could do it with planets, we can go look at this, we can look at that. And off the scope moves. I mean, I remember once when I was doing the ISS, in the middle of the daytime, obviously, because it was a solar transit, and I was in a parking lot in Valencia. This is the day when my laptop shut down. And I had everything all set up, and there was this family that was riding around on their bikes and just basically enjoying a Sunday night, or Sunday afternoon even. And it just caught their attention, and these kids just came running towards the scope because they were so fascinated, thinking, what are you looking at? And unfortunately, their parents kind of pulled them away before I got a chance to even say anything to them. But you could see that look in their eye, and they're going, oh, what is that? You know, it's so cool.
Right. Right. Well, thank you very much, Simon. That's awesome. That's awesome. So
Yeah, no problems.
Yep. So any more news out there coming from the Philippines there, Chris? You're still muted there. Let's get you unmuted. There we go.
Well, it's the same thing here. We're in the monsoon right now, so it's kind of tough imaging. Seeing isn't that great. But overall, we still try, especially excuse me, with exciting things happening on Jupiter right now.
Yes. Right. Oh, excellent. That's great.
Yeah.
That's great.
That's
And
awesome. That's an awesome image of Saturn there. That just is amazing.
is that
Oh,
your?
this is a Hubble image. Oh, by the way, I just want to comment earlier on a comment of since I've imaged it, it's no longer worth imaging. Really, the planets you have to image every day because things change. And right now, we have a guy in Florida who images once in a while, and it just so happened that his image was a confirmation image of the discovery of the storm. So this thing gets exciting. People who are even not normally imaging get to contribute in science.
Where is that stuff logged or these discoveries? Now, how's that communicated when someone confirms a discovery?
Facebook.
Is there
Facebook.
Facebook?
On Facebook,
Okay.
yeah. Someone posted in one of our groups called Pro-Am Community for Jupiter, and when I looked at it and checked that there was no moon, then I knew it was an outbreak. So I told him that he discovered something, and there's this another guy in Miami who also was imaging a few hours after, and he caught it probably 1 hour after, and he caught the same storm. So things move fast now.
Yeah.
I think Scott is out right now.
Checking on something, guys. But well, excellent. I can see that that Matthias Schmidt has logged in here. Are you with us, Matthias? There we are. So Matthias, we've talked to everybody with us tonight. You are you're out there at Cedar Breaks National Monument. Looks like you're actually in space though right now. So
yes, I hitched a ride on the last Starlink satellite. So
great. Well, you've changed your life to take up the challenge to protect dark skies, and you are. We talked a little bit before on another program. You've taken up an internship at Cedar Breaks National Monument to be involved in their Dark Skies program. What can you share with us at this time?
So first of all, thank you very much for having me. I appreciate all these presenters and their amazing knowledge and what they do with their technology and with their ingenuity. So I feel honored to, even though it's really late, but it's never late for an astronomer because you want to look up at the sky when it's dark. So, which is my forte, since I will be starting at Cedar Breaks National Monument, which is an international dark sky location, in 2 weeks, and I'll be the dark sky coordinator, and I will be involved in astronomy outreach, and also running the Master Astronomer program, which is a 40-hour astronomy program for novices to learn about the night sky and also how to work with a telescope. And I want to share a few images with you that I took over the last 2 weeks ever since I got here. So, I figured every astronomer wants more of one thing other than sleep and money for better equipment, which is dark skies. So I lived in New York City for 15 years, and let me share my screen with you. Let's see. So this is the light pollution map for the United States. And I basically lived here in this really white spot, which is New York City, for 15 years. I think this is Jenny Jump in Pennsylvania, which is the closest really good dark site for astronomers, and they have an excellent astronomy and star party. So this is not a very good place to observe the night sky. I joined the local astronomy club 3 years ago, and through fueling the flame through observing my first total solar eclipse in Oregon, I got into astronomy. I got involved into the club more, enrolled in a Master of Science in Astronomy program. And then I got, in the pandemic, I found this urge in me to do something meaningful with my life. So I applied for a job in Cedar Breaks National Monument, which is the national park in Utah. And I moved from New York City here. I drove across the country to Cedar Breaks, which is, let me zoom in a little bit. Let's go to Utah. The Grand Canyon is down here. So the Cedar City is here. It's this spot. And the national park is here. And to give you an idea how, you probably all have heard of the Bortle scale, which basically was created by a astronomer. And he wrote a big article in the Sky and Telescope magazine about 20 years ago. And he came up with a more generic scale for measuring the darkness of the sky, because we all have very subjective perception of how dark a sky is and how bright a sky is, because our eyesight is different. Some have really good eyesight and some have a little bit worse eyesight. So he came up with the Bortle scale, and I'll let me just where's my so the Bortle scale, I'll show you a nicer picture, and then we'll go. So the Bortle scale goes basically from 1 to 9. So 9 is the inner city sky, where you basically see, which is where I have been for the last 15 years, where you basically see maybe the 20 brightest stars at night. And I basically move from Bortle scale 9 to right to the edge between 2 and 1. So if you have ever been to a star party, I was at one in Oklahoma, the Okie-Tex Star Party, which has an excellent dark sky. I actually, on the way here, I stopped in Punxsutawney in Pennsylvania. If you have ever heard of Groundhog Day, this wonderful movie with Bill Murray, who relives the same day over and over again. It's probably around here. So suburban rural transition. So the more I drove west, the darker the skies got. But then again, this is the Bortle scale, and this is a generic scale from 1 to 9. And how do you actually get it a little bit more refined? There is.
We're not seeing the screen update here.
I'm sorry.
At least I'm not.
Let me try this again. Thank you for. Yeah, this one. Okay, so here is a little bit more detailed comparison and how the Bortle scale, which is here in the center, which goes from 1 to 9, fits in with several measurements of sky brightness. And I have a sky quality meter by Unihedron, which is this small, this small box, where you actually measure the magnitude per arc second of the night sky. And so I took a measurement during new moon about 2 weeks ago in Cedar City, and it came out to be 21.68.
Oh.
So which is down here. Okay, so I'll show you a picture of the Milky Way I took with my camera in a moment. So essentially, I went from when in New York, once I got this sky quality meter, I took a measurement in Central Park and it was about 16, which was just a month ago. So I went from 16 to 21.7.
Wow.
And, you know, there is an app on the iPhone or the Android where you can actually, and I encourage that to you wonderful guys to start taking measurements to measure the light pollution of your sky, because that would be really valuable data to have to do local outreach and encourage, you know, cities, for example, to better manage their electricity bill and their light pollution, because all of you have maybe more or less an amazing connection with the night sky and are awe-inspired by what you see. I mean, I see some of your pictures, they're just fantastic. It just helps connect people to this amazing place in the universe in which we live, and especially our Milky Way. So let me just show you just a few pictures that I took so you can actually believe me that I'm not lying when I tell you the skies are really dark. So, and by the way, all of you are always welcome. There will be a star party, the Southwest Astronomy Festival next year in September. So all of you guys are welcome to come to this star party. I don't live in a big house, so the first 3 people that message me after I'm done, they can stay at my place. Okay, sorry, Scott and Jared can stay at my place, so maybe one more person can stay in my place.
More, yeah.
That's awesome.
More. And I'll put a tent up in the yard, so 5 people, okay?
Okay, cool.
So let me, so which one? This one. I want to show you this first, okay? So this is, I took this picture 2 weeks ago with my Sony camera. This is 10 seconds. The ISO is 25,600. And the measurement of the SQM was 21.64 that I took. And you can see, you know, this, it was really difficult for me for the first few days because I'm supposed to be the astronomy educator and teach people about constellations and star lore, to figure out the constellations, because there were so many stars. And I just had trouble taking out the constellations. So I used a lot of help. You know, I used my my app on my phone to make sure that I'm actually looking at the proper constellation and the star. But there's an amazing amount of stars. So, you know, Jupiter is here, Saturn is here, the Milky Way, Sagittarius is down there. Here's the center of the Milky Way. So this was one image that I took, and I went just one night. I went camping to a campground. Actually, let me show you this one before I go to the campground picture, because I took a picture with the camera of the Andromeda. And I'm a beginner in this. Some of this is astrophotography stuff. Okay, so so here's the picture of the Andromeda. Okay, this is with my 70 millimeter. This is 6-second exposure. So here you can see the Andromeda galaxy, and it's
wow.
You're not gonna miss it. You're not gonna miss it. You know,
you would easily catch that naked eye.
Yes, you easily naked eye.
Yeah.
So, and then let me just show you the picture of the campground, which was the even better, this one. Okay, so this is the SQM 21.94. This is a Bortle 1, and this was even a little bit better than the Cedar Breaks National Monument. And here again, you have Jupiter and Saturn, and the Milky Way is just striking in its detail. And you know, this is a 30-second exposure, so of course you see a lot more because your eye does not capture the Milky Way like this. But you can make out, as soon as the sky is dark, you can make out the Milky Way in its amazing detail with your naked eye, and it fills me with wonder and awe to be in a place where every time I look up at night, I can see that many stars and an amazing richness of detail in the Milky Way.
I remember, Matthias, that the first time I saw the Milky Way out west like that in a really, really dark sky, I'd never been in a dark sky like that. I saw the Milky Way up near the horizon. I said, "Is that clouds coming?" I thought it was actually clouds on the horizon, like a storm or something was coming.
Yeah.
It looked kind of like that, you know. So that it's just an amazing thing to see. It's like the difference between, you know, I experienced my first solar eclipse in 2017. It's like the difference between a partial eclipse and a full total eclipse. That's the big difference.
Yeah.
Yeah.
You know, the funny thing about, you know, you mentioned that about clouds, thinking clouds are coming in. When you're in truly dark skies, you know, the clouds, you can't really see them. They just start blotting out stars. There's no light underneath them reflecting back at you.
Yeah.
You know, I had that experience where you notice that stars are missing. And, you know, I was taking pictures at the time, and you look at the pictures afterwards and you can clearly see there's a giant cloud there, but visually it's hard to even recognize that's what it is.
Yeah. So in a few weeks or in a month, I'll be worked into my new job, and hopefully I'll be able to give you a better overview of what we do here.
Exciting so far. It's great.
It's exciting so far. Yes, it's very exciting so far.
Yeah, wonderful. Well, we have Dave Ing joining us, and he was chatting online and caught my attention and said he had an image he'd like to share with us. So, how's it going, Dave?
Oh, it's going better now. It's been kind of frustrating the last few hours. Installing a new camera on my rig, I replaced the DSLR with a cooled ASI 294 Pro. And when I did that, it changed the focus point a lot. So I had to find the focus for the new camera, but then I have an off-axis guider with my guide camera, and that messed up the focus. And it took me forever to figure out that I just needed to remove my helical focuser, and I had to search my house for the stock little clamp
right
with the off-axis guider, so that I can actually push it all the way down and get it close enough to where it would focus. Anyway, I think I finally got that done.
I wanted to, Marcello just sent a message to us saying that he needs to call it a night. Marcello, thank you so much for joining us all the way from Brazil, sharing your knowledge about cosmology with us, and hope to have you on another program in the future. Thank you.
Thank you very much. It was a great pleasure. Thank you very much to meet all of you.
Thank you.
For me, it's an honor
Marcello.
to be here.
Yeah, thank you. That was a great presentation.
Bye.
Thank you very much. Thank you.
Bye-bye.
Bye. Thank you, Scott.
All right. Now back to you, Dave.
I also wanted to say to Matthias, I think that's an excellent program, and about having your clubs or people, look at your night sky and light pollution and do something about it. My club actually is starting to give out awards for local businesses that both make an effort to curb light pollution, and also they want to recognize companies that actually have too much light pollution. Send them a little notice saying, hey, you're actually polluting the night skies. So that's what my club is doing here, to try to help recognize people that are actually doing a good job for that, and then also recognize people that could do better.
Right.
Anyway, from last week, I was capturing the Bubble Nebula, and let me share my screen here. Can you see that?
Yes.
Oh, okay, great. So I actually have a few different pictures here. This is one that was just stacked no processing. And you can see down here, I think this down here in the lower left-hand corner is from my off-axis guide. I think the prism kind of sticks into the frame, because I noticed this on all of my pictures. But you can also, well, let me go to the next one. So I cropped that out. This picture also is not processed yet, but I wanted to leave it in here to show you the noise that I was getting. You can see all this red. You can see these lines in here. So that was kind of a pain to deal with. And this third picture, I actually, I think this is where I started to do some pre-processing.
Are you dithering?
Yes, I am actually. I've looked this up and I understand this is considered walking noise and that dithering is supposed to take care of this. Now I was dithering 1 pixel every 4 frames, so maybe I wasn't doing it enough.
Yeah, I mean, generally you'd want to dither out at least a few pixels if you can, and more often.
Yeah.
You know, if you're not taking a lot of subs, the limited number of subs every frame is appropriate.
So what I'm starting to do now is, well, tonight I started with my new camera. I'm actually moving over 3 or 4 pixels instead of just 1 and doing it every 2 or 3 frames, I think. We'll see how that works out. This one is after some processing. It's my first attempt. I went through the PixInsight Easy suite, where you just click on a few buttons and it does the deconvolution for you. It does the automatic background extraction, dynamic background extraction. And then finally, this is what I ended up with.
Oh, wow.
So that came from, and then here's the first image. It's just a little comparison from here to that.
Very nice.
So.
Very nice.
Yeah, thanks. But I'm hoping that as I progress along, I'll get better at PixInsight. You know, I keep following different YouTubers and whatever I can read on the internet, but I actually visited your site, Gary. I may end up enrolling in one of your programs. And then this is, let's see, where is it? I have one image of what I'm doing tonight, what I got so far just a couple minutes ago. I'm shooting the elephant trunk. This is 1 sub on my new camera. This right here is amp glow that I heard the 294 has. And yep, it's right exactly where they said it was going to be. I understand that if I do the calibration frames, I should be able to get rid of that, or at least
yeah, your dark frames will pull that out completely.
I don't know how well this image is coming across, but I think you can see some of the structure here and over here and over here. I think these are probably just dust on my.
Yeah, that's your flats will take those out.
Yeah.
Isn't that amazing? These calibration frames, you can just fix so many things. So
yeah,
it's great.
So anyway, that's what I had to share. And
all right.
What I've been doing the last couple hours is dealing with this. But it looks like I'm on the right track. So I think I got it going.
That's very cool. Well, I promised that we would show some microscopic animals too. So I actually got tardigrades in the mail and some green hydra. Okay, so I hooked up my microscope, which you can kind of see behind me here, and that whole thing is now connected to Zoom. So you can see the microscope slide here, and I've got the lowest power on it. And this is just a drop of pond water. I'd spent roughly, with shipping and everything, roughly $90 or something like that to get some stuff next day aired out to me, because living animals have to, they have to ship them quickly, and I have them and everything. But Kent Kent Martz got me some pond water out of his horse tank from his farm. And lo and behold, there's a ton of different animals in here. And I'm going to switch. I'm going to show my my screen here. So let's see. Here we are. This is through the Bresser Science Infinity microscope, and I'm at its lowest magnification, which I think is like roughly like 40 power, something like that. And you can see towards the middle there, you see some activity in the moss, and those are tardigrades eating away there. So I'm going to switch magnification.
That's my stuff.
That's your stuff, yeah.
Hi, everybody.
Here we go. And let's see. So you can see in between those two pieces of moss, you see something moving around, and that is a tardigrade.
You said this was Kent's drinking water?
Yeah, this is Kent's drinking water.
It's very flavorful.
Oh, and there goes like a paramecium or something swimming around.
You know what would be really scary, Scott, is if this was just regular drinking water.
So the software that comes with these Bresser microscopes is actually pretty cool. It's attempting to do a auto exposure here, but let me pull down the exposure time.
Well, I want something big.
There you go. Yeah, there's some big stuff in there.
There's some little stuff.
Yeah, you can see him. He's moving around in between there. But yeah, I promised that we would show these, and I think it's very cool. I did a video a while back of tardigrades, and just in the course of the day, I had almost 100,000 views. People love to look at them. I mean, they're just fascinating creatures. And there's so many different kinds of things, you know, in the microscopic world. So the universe doesn't start or stop anywhere. It's just amazing, you know, with different optical instruments, what you can see. This setup that I have here is roughly about $1,000, and you know, it's you know, you could do research with it. You could just explore the microscopic world with it. So, and being that, you know, I'm never able to go out there with my telescope when I'm doing these star parties, you know, I figured that this would be my way to look at the universe tonight. So,
well, it's kind of interesting when you think about the reason we're trying to go to Mars and we're searching for life in the universe. And this could be very similar to the life that we might find somewhere in Europa or someplace like that in the future.
Of Mars, that may be very true. It would be really cool to find out that it's rich with microbial life. So,
More drinking water for Kent.
That's right. That's right. Simon, are you still with us?
I am still with you guys. I mean, I set all this stuff up, so I'm not going to break it down in less than an hour. But you know what? I'm going to show you guys a couple of things real quick.
Okay.
So I'm going to actually share the screen this way because you want to see the full resolution of it, so to speak. And then you probably see me in a little corner here, but it's not Jupiter that I'm showing you. It's just it's still up and running. So let me move this screen thingy out of my way, even though you guys can't see it. We were talking about looking at some of our old pictures and how far we've gotten. So I thought I'd dig out some older shots. Unfortunately, I can't get that far down into my Instagram because I have too many posts, so it just won't get to it. So I was looking at the guy who posted that picture of Orion. Who was that? I know he was hiding in here somewhere. Who was that posted the picture of
posted Orion?
Yeah.
Wade? Yeah.
Oh, that was Wade. Yeah, so it kind of reminded me of where I was and where I am now. And the funny thing here is that this was actually not that long ago, but I wish I could have showed you the picture of Orion that I first took, and it was this hideous blob that I got with a 200mm Canon L lens on a DSLR with no tracking. I mean, we're talking 2-second exposures here at like maxed out ISO and stacking 1 million frames, literally. And the more I started to get into this, because that's what actually got me into doing astronomy in the first place, the more I started doing it, the more I started to learn. And every time that I would capture Orion, I eventually built up a picture till I got to this point here. I mean, I don't even want to know how many hours worth of data has gone into this picture, but that's a version of Orion that I ended up getting.
Beautiful. That is beautiful.
Wow.
And it just shows how crazy everything actually is, and the fact that we can't actually see any of these with our own eyes. And the funny thing here is when kids come up to me and ask me, it's like, oh, wouldn't it be so cool if we can go into space and see all of this stuff? And the sad truth of it here is the closer you get to something like this, like Orion, the less of it you can actually see, because the gases that you see are so heavily diffused and the molecules are so far apart that when you get closer, they look like they're moving further apart to the point where you just simply don't see it any longer. Yeah. So it's weird from our perspective that we get to see things like this, but I can only imagine if there was actually life inside of the Orion Nebula and they're looking out at us, and for all we know, we're inside of a nebula. Apparently we are.
Yeah.
And they have no idea that they're surrounded by all this craziness.
Right.
And then, of course, there's the Pillars of Creation. This one was, again, a collection of all my data crammed into one big massive image over the time that I've collected. I believe there was another guy called Tim. He ended up sending me some of his data as well. So it's really good fun to collaborate with other people. And it's almost like a challenge for all of us, that if you can imagine 100-hour Wade sending his data out and then somebody else getting another 100 hours and this guy here gets 50 hours and you combine all this data together, you know, we're going to end up with one hell of an image.
Yeah, right.
So yeah, it's
beautiful.
It's something that I'd love to see. I mean, if you can imagine all of us getting together and showing off everything, but what happens if we combine all our data together? I mean, what kind of monstrous thing are we going to end up with?
Well, if it's me, you're going to have a tardigrade in there. So
but that's all right. They had tardigrades in Star Trek, so why not in our space pictures?
That's right.
If we all combine our pond water.
Oh yeah. Well, if we end up combining our pond water, I think we'll end up with cement or something.
Wow. Well, it's been a lot of fun, you guys. If anyone else has anything else to share, you know.
I've got one more question, I think.
Yeah, you do have one more question. And guess what the prize is? Ooh.
Oh, man, look at that.
Announce the winners of the last Star Party. But this is an AR-102, a smaller version of what Jason is using to do narrowband imaging with. He's using a 6-inch model of this, but this is the 4-inch.
That's a great starter for narrowband imaging.
Sure. You know, nice 4-inch aperture f6.5. And so
it's not a great starter. I mean, that's I would like to have that right about now.
Right, I would too.
I have customers that have the 4 inches doubletta chromatic and are making amazing pictures. They don't suspect that is an excellent option for astrophotography to start. It's excellent.
Yeah. Oh yeah. Yeah, I think that you can do. I mean, after seeing some of Jason's,
I just stacked another HA image if you want to see it.
Yeah,
while we were sitting here.
Yeah, why not?
With the 152.
Yes. Yes, I can confess that I changed the option to my customer from another brand.
Yeah.
Another brand in the market of the same size of 4 inches achromatic refractor, and because the another company don't send me the option, but the difference, of course, that he can put a little of difference in money, but when he received the OTA, he was amazed with the difference between the another brand and the 4 inches from Explorer Scientific achromatic, because it's the same mechanic, it's the same structure, all the same, that apochromatic with the achromatic.
It's great. And this shot right here, what is this object?
This is the Wizard Nebula.
Oh yeah.
I'm sorry, I don't remember the name. I think it's NGC 7380. Don't quote me on that, but so this is 5-hour hydrogen alpha integration.
Beautiful.
Yeah, so it's and this is unprocessed. I just stacked it, and this is a screen stretch. So
wow.
What's exposures, length, and how many?
so this was shot with 4-minute exposures, and the camera's an ASI 183 mm.
Oh.
So the scope definitely makes some great data. I'm really impressed with this. I mean, the more you zoom in, it's great quality.
It's great. It's beautiful. Look at all that. It makes me wonder
Amazing.
how planets are out there around all those stars.
Yeah.
Oh yeah. So
all the tardigrades out there.
Yeah.
All the tardigrades and all the mud out there.
You know, the funny thing here is though, it really does look like a wizard. It really, really does.
I still can't see the wizard. Never been able to see this wizard.
What, really?
Yeah, I don't know. Where is this wizard?
It looks like a guy with his hands held out. I mean, there's no other way. In fact, let me see if I can demonstrate. I mean, I don't have the hat, but he's doing this.
This is actually maybe the first time I've actually seen this, but I
see,
you gotta rotate it.
And the mouth, and it's his shoulders, and those two.
See, there he is.
So these two, this is his hand, and this is his hand.
Yep.
Yeah.
And then you can see the
And you
big
can see
pointy
his-
hat and
yeah,
his
the cone
beard.
hat.
Oh,
The
yeah.
cone- yeah, he's got a cone hat.
There's
Yeah.
Gandalf.
I mean, the funny thing here is like people see a skull in the Rosette Nebula sometimes, which is a funny one. That's a tough one to see. But the funny thing is, though, once you see it, you cannot unsee it. That's the sad part.
That is the sad part.
Yep.
All right. So the question.
Very cool. So what's the question, Jerry?
The question is, this is the last question for the big prize, is when does Halley's Comet next pass closest to the sun, which is called perihelion? What date does Halley's Comet next pass closest to the sun, or the perihelion?
Send your answers to Kent at explorescientific.com.
You think that's a fair question?
Yeah. Anything's fair when it comes to how hard you want it to be, Jerry.
Well, I want people to work for something. I want them to learn things while they're searching for it too. That's really the key goal is for me, is to get people interested in what they run across when they're searching for the answer.
All right, that's cool. Well, I am holding in my hand the European version of our Star Party, which was on the 28th, I guess. Of question 1 was how many objects in the Yale Bright Star catalog? And the prize was the person's choice of a 52-degree eyepiece. The answer, the winner's actually with us here. Who do you think it was, David? Dave Ing is the winner, 9,100.
Oh, wow.
Oh, cool.
Yeah.
Yep. Congratulations, Dave.
Oh, thanks.
Yeah. There we go. All right, and question number 2 was, the IAU Minor Planet Center certifies observatory locations and assigns a code to each of these observatories. If you were to look for a list of MPC observatory codes, what is the name of the observatory signed to W54? And the winner, once again, is Dave Ing.
Oh, wow. That's cool.
Oh, Mark Slade Remote Observatory. So congratulations, Dave.
Wow.
Yeah.
Got fast fingers.
You were good. Question number 3. Okay. And that was for another 52-degree series. Okay. So then question number 3 was, what is Jerry's local astronomy club name? The winner was Brett. We've got his email address here. I won't say it on the air, but and it was the Rappahannock Astronomy Club, RA Club, and that was for an 82-degree eyepiece of choice, in the 1.25" size. And then question number 4 was, where in the United Kingdom is the Beckington Astronomical Society located? And the answer was Beckington Village, Somerset, England. And the winner was Choksta, okay, who actually was on the program. So very, very good. How come it's the same audience every time? And then for question number 5, okay, was for an AR 150 or 102. The question was, how many miles in total did the Cassini spacecraft travel in total?
Wow.
The winner was Zach Kruger, and the answer was 4.9 billion miles, which is pretty amazing.
That wasn't my question. That was, whose question was that? Was that David Levy's? I can't remember who came up with that question.
I don't know. But those are our winners, and we will read off the winners for at the next star party, which is of course next Tuesday. And I am already starting to send out or make up the invites and posters and all the rest of it. Richard Grace, the only guy I didn't do a poster for was for you, and I just didn't have time to get to it. But I have your portrait now, so we'll do that. And of course, all of you are invited for the next star party. You know, Gary Palmer and I are dreaming up this Norway to Australia event, but that doesn't preclude anybody from the United States or anywhere else from joining. You know, if you got something to share, whether it's images, solar images, live stuff, no fake stuff, it's all got to be real. Please join us. We're going to see a lot more of Libby and the stars. That was such an amazing first section of our star party this when we got started. Libby is, she says she's going to do, I guess, distant galaxies is going to be her presentation. So that's going to be very cool. Little 10-year-old Libby. I promise to bring on more microscopic animals because I love them. And and I sense that they love me. So, you know, somehow, especially those water bears, the tardigrades. So anyways, I want to thank you all for watching.
Scott, real quick.
Yeah.
I'm just going to show everybody a solar animation real quick before we run away.
Okay, let's do it.
All right, so share screen. So this was taken
Wow.
yesterday. This is actually a 3-hour time lapse.
Wow. It's beautiful.
And then you'll see another close up of the other section.
Like,
it looks like something just blew up a dust storm over there.
Oh my God.
And then these are ones from a few weeks back.
Yeah.
I just did like a compilation type thing.
Look at that. Look at it just looks like melting candle wax or something. It's crazy.
Awesome.
And this was taken a while ago as well. But it's just goes to show how crazy things can get on the sun.
Yeah.
I feel like this time around, like, we've been in the solar minimum, but the technology's come so far in the last few years. And once we get back to solar maximum, I can't imagine what kind of images we're going to see.
Yeah. Because
I don't even know what I'm going to look at during solar maximum. It's going to be just nuts.
Yeah. Yes.
Simon,
yeah.
Why was the color on one orange and on the other one it was kind of grayscale?
So depending on what I'm trying to show, sometimes I do high contrast imaging. So if it's like very, very high contrast, then to make it go color is really strange looking. So it's better just to leave it in monochrome because I shoot all my solar in monochrome.
Hey, Scott, that might be a decent door prize as a solar filter. You guys sell those, don't you?
We have white light filters, but I don't do any H alpha stuff.
Yeah, I meant the white light filters.
Yeah, sure. Yeah, we can do a white light filter. No problem. Good idea. Good idea. So we'll do that at the next Star Party. We'll give some of those away.
I'm gonna have your paycheck, Dave.
And I think, oh yeah, I got another tardigrade right here. Munching away, actually a couple of them. That's a good view of a tardigrade right there. All right, I'm going to share this. You can see them up there at the top. There's another one down there at the bottom. And they just love grazing on this moss.
The funny thing is they're just completely oblivious to us.
Yeah, we're in another universe. That's right. Oh, there's two of them, see? There's two of them right there.
I wonder if aliens are looking at us like that.
They're completely oblivious to us.
Yeah, I could watch these guys all day long. It's so cool. And those are pretty big ones, they're probably still smaller than a millimeter, but it's a good size for a tardigrade.
Well fed.
Tractable animal. They're able to survive the now you can start to see its feet as it's climbing around. What's also really interesting is to watch them, their body, if they dry out, their body forms like almost, in fact, I guess it's described as a glass shell. I think it forms like a silicone-like shell around them. And they're able to survive dried out for years. They get back in water and they're able to rehydrate, and they will climb. In fact, if you look to the right of the one that's really active, you see a transparent body there, and that is a body that one of these tardigrades has climbed out of its shell. So it was dried out before.
Oh, he's really going for it.
It's time to eat, man.
You think he's got some ranch down there with that?
Some ranch.
Yeah. He's getting on that other one. He's like, wake up. I need.
The other I think he's sleeping or something. They do go into this state of, I don't know, preservation. And you can see his little eyes there. He's just covered in moss.
What magnification is this?
This is, I know it's over 100 magnification. It's probably more with the camera and everything. It's probably something like 300 or 400 magnification.
Okay.
What's the max on that thing?
Depends on which objective you put on it. I have 100 power objectives, that I can put on it. So you can go over 1,000. He's trying to climb out of my field of view. He's shy. I think he now is suspecting that we're watching him. I'm just barely touching the stage adjustment right now. And you can see that I'm just like putting slight pressure on the stage adjustment to get that centered up. And then you can of course, you can just zoom in on it too. You can do this, and you can see. And then there's a 2-speed focuser on this too, just like on your telescopes. So, if you're into astronomy and you have some cloudy nights, microscopy is also a great way to go. And you can either shoot with the software that comes with it. You can capture video, or you can capture stills and process them. Probably use all the same processing techniques that you use in astronomy. And yeah, he's just tearing it up. I had heard that that they had crashed something on the moon, and that it actually had tardigrades on board.
Uh-oh.
Yeah, and so there may be a contamination of tardigrades on the moon itself.
They're not tardigrades anymore.
Yeah, they're 18 tall.
Right. Gonna have to call Sigourney Weaver or someone.
That's
to
right.
handle those dudes.
That's right. Kind of mesmerizing, these things. And I was looking at the green hydra earlier, but those are truly tiny, and I didn't get the right objective lens out. So I'll have to do that for the next live broadcast or something. But I'm having fun watching these guys. Yeah, and it's cool too, because I really don't feel bad if my glass slide will dry out, which it will. It's just a drop. It's just a drop of water underneath the objective, and they'll dry out. They will dry out. They'll form their glass-like body, armor on them, and then I can just reintroduce more water later on, next year sometime, and they'll come alive.
Wow.
It's just amazing. Super, super duper. Yeah, you can see his legs are like waving. He's waving at you right now.
Have you named him yet?
I think I'm going to call him Terry. Yeah, Terry Tardigrade.
Now you can't get rid of him. You got to keep him.
Yeah, that's right. That's right.
Don't ever name them or feed them if you do.
Right. Don't get emotionally attached to these things, because they'll ruin your life. Mm-hmm.
Sorry, I didn't realize I was looking at the moon, and I've just got some massive close-up of it right now. This is nuts.
Go to the moon. Let's check it out. I'll stop sharing here.
Yeah, I'll do a screen share as well. Oop. Might be easier that way. It's excessively high res is all I can say.
Oh, wow. Look at that.
Yeah, I'm literally just looking at the edge of some random... I'm trying to move the scope around. I'm like, oh, what's this? And then it's like, oh, okay, it's the moon.
Beautiful. What Jerry, can you tell us what crater we're looking at?
Yeah, I'm just looking at that. I'm wondering if it's. I'm thinking it's near Wargenton, which is a shallow. Really, Wargenton is a crater that's like a overflowed uh, bowl. You can see there's really this is. I'm thinking this is near the region of that. I don't know. Maybe you're really zoomed up really close. It's hard to tell
Yeah,
when
we're
you're
on a
zoomed up
limb.
this. Yeah,
I'm on a limb, but
so I don't know if you can. I don't know if I guess your optics are set up fixed for that scale. So maybe scroll up a little bit on the limb and let me see if can recognize anything.
Look at the shadow. Oh, that's so cool.
Well, that's the neat thing about the limb is you could pick out mountain peaks that stick up above the limb of the moon.
yeah, this is a 150 refractor.
See that mountain right there? See that right there?
Damn.
The shadow behind the mountain.
Any minute now, the tardigrade that they left there is just going to pop up.
There you can see the little grades out there.
Oh, look, you can actually see the inside of the crater here.
Oh yeah, it's like you're in a high flying aircraft flying over the moon, and you can see down. You can see the central peak there a little bit. You can see the shadow of the rim.
Well, I mean, I'm on 5x
Yeah.
Barlow with
Yeah.
the 150, and this is what a 462, one of those new cameras for QHY-ZWO. Both make the same camera. So this is actually the first time I've used it.
Yeah, this is a zoomed up. This is very high magnification. But you can see the mountain there on the left. You can see the mountain and the shadow behind it that is casting. It's kind of cool.
The lunar lander that spilled the tardigrades was from an Israeli. It was called the Bereshit lunar lander. It carried thousands of books, DNA samples, and a few thousand tardigrades to the moon. So let's see, what's the story here?
What do you think of that camera?
This camera?
Yeah.
Oh, you know what? I've seen dozens of astronomy cameras now, and I wasn't expecting this to be something weird like this, because when I first got it out, it was like bad seeing, so I didn't even bother with it. But I took a picture of myself, and the first thing I noticed is I've got very, very dark colored eyes. They're like brownish black almost. And I had the camera right in my face, and I took a picture of myself. In fact, I got a picture of it on Instagram, so we can actually look at it if you really wanted to. And it's just crazy what it sees. Oh, gosh, yeah, there you go. That'll scare the snot out of you. And it's just
infrared.
Yeah, that's the infrared. I actually had a 680 nanometer IR pass filter, so anything below 680 is blocked, and just held it up to my face just to see if I could see anything, thinking, this thing's going to be like overrated. No, it was clear as day, and I'm like, this is just nuts. I could see the veins in my neck. I looked at my arm. It's just nuts. I've never seen an astronomy camera like this. And then for the price of what I paid for it, it was like, what?
Yeah. The moon's beautiful, man. Look at that.
Let's see if I can find anything else. I mean, I don't know what the orientation of the moon is right now, but this is just...
Do you have the IR filter on there right now?
No, there's no filters on there, because obviously I was doing Jupiter. I didn't want to block anything out. I mean, I'm working my way around the edges, so it's usually the most fun part. Just to see if I can spot anything else. Gets relatively smooth here.
Yeah, that's the lit up part of the limb of the moon. That's really the...
Yeah, it's starting to blow out a little bit here, but there's not as much action on here. It's just good to scoot all the way around.
What a desolate place, man.
Hey man, I'd love to live here.
Would you?
Sure. Nobody will ever bother me ever again. Well, you want to do a star party? It can't get any better than doing it on the moon.
Perfect seeing all the time. That's true.
Oh, here we go again. There's another.
I'm
That's a nice one.
Yeah.
I'm impressed you took us all the way around without a single wrong turn.
Right.
You must have been good at the Etch-a-Sketch.
The seeing is really good. I mean, it's really pretty stable.
This is pretty
at
high.
that magnification.
Oh yeah. Look at
Okay,
that.
we're back.
Like it's got like it's kind of spilled. If you go back down a little bit there. See that? It's got like something spilled off to the side there. Was that, do you think that was from lava or what do you think?
Anything.
That's those are, so this, you see the shadow behind it into that crater. There's a lump of like a mountain range along the edge of the crater.
Mm-hmm.
That's in the at the top middle. Is that what you're talking about? There's kind of, and then there's a little lava.
They're kind of closer, and it's got like this little valley going into it.
Yeah.
Is that just a mountain in front of the crater, or what do you think?
No, that's part of the rim.
Yeah,
I think.
It does kind of look like a valley dropping in, though.
It does.
I mean, this is all parts of the moon. I mean, we're literally looking at parts that we just don't normally see. I mean, I'd love to see the other side, because there is this great big crater on the other side of the moon, which we refer to as the dark side of the moon. That,
well,
it's,
you know, you could probably go there sometimes.
well, I'll see you there then, Scott. You know what? I tell you one thing. When SpaceX does the Starship launch, because I know there's that guy who paid to do his own private thing.
Oh,
I swear,
yeah.
if I ever get a chance, I will try and sneak aboard that as a stowaway, just to be able to go around it.
Mm-hmm.
Yeah, that's gonna be a cool trip for those guys. And
Yeah, amazing things are happening every day, man.
We can see the inside of that crater.
Yep. Oh yeah.
yeah, you can see the central peak there, and then you can see a little bit of shadow from the rim that's closest to us, casting a shadow on the floor of the crater.
Mm-hmm.
God, you know, we can sit here all night looking at this. I think the show was supposed to be over.
You know, actually, the best part of the show often is at the very end of the show.
Yeah, I guess so.
Everybody kind of relaxes. They start to pull out all their stuff, and you know, so it's.
I know it's only 11:20 for me, so
Yeah,
Yeah, it's 2:20 for me.
yeah, it's 1:20 here.
See there on the right hand side, you got these little mountains there.
Mhm.
That crater right there
Oh,
is what he's looking at.
oh, I see.
So I
So
don't have a, it's just above.
Kent just came in with a map. He's got it figured out. I don't know.
Oh, okay.
Sorry.
Hold that map up so maybe Jerry knows it.
Yeah, let me stop the screen share so you guys can get a close up.
That crater right there. That's what we're looking
Okay. Let me see. I don't see it full screen.
past this mare right here. It came right up here. So the shadow, it's almost full, comes right in through there.
Mm-hmm.
That's
So it
that.
looks like so you've got south up on that picture. I'm used to looking at south down, but that's on, yeah. So that's the way I'm used to look. So that's Mare Crisium there on the right, which is where near that crater was on that limb.
Right there is what we're looking at.
Yeah, so
We're right in between the rabbit's ears.
yeah, if you see it as a rabbit. I see that as a woman's face looking up looking up towards the left, upper left is the woman's face.
I see it as a rabbit. So you got the ears.
The ears right here.
Yeah, the ears coming out
Thanks.
right here.
Body.
Right. And the bunny rabbit tail. That's cool.
You know, it'd be really, really cool right now is if a meteor just hit it.
Yeah.
That would just be like the end. It'd be the greatest sign off ever.
It's kind of how I want to go out. The people, different people say, well, if you had to choose how you end this life, I want to end this life by looking up at the sky and seeing a meteor coming in and just smacking me in the head, and then they just preserve it, right? So
Your head or
the head with the meteor still in there, right? That'd be okay.
The day before the election, right?
I don't care what day it happens. Yeah, I'm going back to the tardigrade here for one long last look.
No, don't we have that big or that close? I don't know if it's that big, but that close asteroid.
Yeah, the day before the election.
The day before the election.
Yep. Tardigrades can grow up to 1.5 millimeters, and if they have sufficient food and water, will live for about 2.5 years, which is the average age of a guinea pig. So there's that.
That's a pretty long time.
But they can be in a suspended state of animation for years with no food or water.
But I found it fascinating.
Oh, here he comes.
I found it fascinating that something so small can live 2.5 years.
Yeah. There he is.
Is that one of yours, or is that?
Yeah, this is one of mine. Yeah, we already looked at yours.
Yeah, I saw that. Heard you stuff gone.
Yeah, now there's over 1,000 different species of these things.
It's amazing to read about them.
Yeah.
So for those interested in lunar observing, I use a program called Virtual Moon Atlas, which is free. It's a great atlas for your computer to identify craters on the moon. I use it all the time.
Hey, Jerry, we need to rig up a PMC8 system on
a microscope
so people can run it remotely.
Well, I talked to Scott about running the XY stage, and you could actually track an object on the, with the mount controller. Keep it, I don't know how fast we could make it move, but you could maybe track an object all around the slide. Lock onto it.
Quick. There's a little tiny thing flipping around here.
Look at that, yeah.
It would depend on how fast your camera is, what your frame rate is.
Let me get a little bit more light on it. The other way, Scott. There we go. Now you can see the inside of his body.
He's looking up and say, "Turn that off.
Turn that light out."
I'm trying to eat here. It's getting hot.
So Scott, you just scoop up a little pond water and you're sure to find them, or did you have to search for them?
These I bought from Carroll Biological, but the other ones that we looked at were gathered from Kent's horse tank. So, but where you can find them, I mean, they're everywhere. They find them underneath the ice in Antarctica. They find them on, I guess, thermal vents. They find them in moss. They're aquatic animals. But man, they can. Oh, now you can see the exoskeleton of one of them, right there. So that one probably climbed out of that, and he's going to town. It's time to eat.
Yeah, you can see the little legs on that exoskeleton. That's cool.
Yeah, you sure can. You can see everything.
I think it's time for bed.
It's time for bed.
Oh, I'm gonna wait for Mars to come up. So
Oh,
it's not up for you yet?
I'm gonna wait for it to really get up there, probably around about 60 degrees. So 3 o'clock in the morning, maybe 4.
So are you going to broadcast or?
Well, if you want to run this until 4 o'clock in the morning, my time, that's up to you.
I don't think I can handle it. I also have a full day tomorrow. We've got morning marketing meeting to get involved with. But I am having a lot of fun, and so this is great. Oh yeah, look at him. He's gonna. Hey guy, he's eating up all the moss and anyhow. I'm gonna stop sharing. And I just wanted to say thank you. Thanks, Dave, for coming on at this late hour. Simon, your expertise in broadcasting, sharing, and image.
No problem.
Amazing, Jason, your work is incredible to look at every time, Astro Beard, thank you much for showing your cool setup, all your new equipment and your images. You're getting better and better all the time.
Thanks for having me on.
Yeah.
Just don't try to take that case on an airplane.
I carried the PMC-8 when I traveled back and forth, and they ripped my case up.
Yeah.
Looking at it.
They don't mess around.
Actually, I had something very interesting happen. I meant to say this earlier, but when I went camping last fall on my way out to West Virginia, my alternator died. And I managed to use said case to get to West Virginia, use solar panels to charge said batteries, and drive all the way home almost 3 hours with no alternator.
Yeah, with no alternator.
Yep.
Jeez.
Lucky to have the power on board.
Oh, yeah, that's right. You can never have too much power. And 100-hour away, that is an amazing image of that planetary nebula, man. Thank you. Thanks for sharing. And I'll thank Terry the Tardigrade, for putting on a great show. And we're going to conclude. So I want to thank everyone. We will be back next Tuesday. Jerry and I will be on tomorrow for our regular program at 4 o'clock. And I'll make an announcement when Libby's ready for her next presentation, which might be at the next Star Party. So we'll have to check that out. But anyways, as Jack Horkheimer would always say, keep looking up. I do want to thank our sponsor for door prizes, which is the Astronomical League. I want to thank the Clear Sky Network for letting us broadcast on their channel. I want to thank cloudynights.com, the forum for broadcasting us on their homepage, which is great. And so that's, I think I've thanked everyone. If I've missed anyone, thank you. So have a good night, and thanks for hanging in there with us. And we'll be back once again next Tuesday with another global star party. So take care.
Yep. Thanks, everyone.
Good night.
Yeah. Thank you. Thanks, Scott.
Thanks.
Good night.
Didn't listen to the broadcast. I did reports and worked and processed orders. Caught up a little bit. Got some stuff for you to look at. We're still alive.
Yar, the pirate ship explorer scientific.
Arr.
Arr.